So, hello everyone. Welcome to Materials World. So, we are going to solve GATE 2024 Polymer Science paper one by one, and it might be long, so please bear with it. And you're going to learn a lot here. So, just for a reminder, we are going to start new batches from May 2025, and for that you can obtain up to 50% to 100% scholarship. Usually, everyone's get from 50 to 75%. And that's the whole idea, to help you all. So please attempt our scholarship test, and if you're not able to join our regular batches, you can join the test series that is going to start by hopefully around October, November. Okay, so that's all from my side. If you have any query or any help regarding any topics, any question, you can reach me through Telegram. So I'm gonna leave my link to the Telegram descriptions. You can just reach me at any moment. That's all. Let's start the solution. Okay, so as usual, there will be always three type of questions. So easy, medium, and four type of questions actually. So very easy and medium to moderate, and difficult. So one mark questions will be blend of both of them, easy as well as difficult. So, so easy means directly memory based. Either you know or either you don't know. So this first question is obviously the memory based questions, like phenol formaldehyde. You all know it's going to be the uh, condensation polymerization. And any one of you, can you tell me what is the monomer for phenol formaldehyde? Anyone? Yeah, please go ahead. Hello. What is the monomer for phenol formaldehyde? If you're going to have condensation polymerization, how to make phenol formaldehyde? That's very.
Phenol and formaldehyde.
Which formaldehyde? What's the monomer for
Phenol,
phenol formaldehyde?
phenol and formaldehyde.
Okay. So that's all. Okay. So you're gonna have condensation polymerization, and it's just directly. So second question is a bit a topic of discussion we can have. So melting phenomena in a semi-crystalline polymer is first which kind of which order phase transition. Okay. So whether a reaction or a transformation is first order or second order. Okay, the transformation is thermodynamically first order or second order. That is going to be decided by the whether the equation that governs that transformation uh, in terms of G. So whether the equation, okay, that governs that transformation in terms of G is second order differential equation or differential equation or first order differential equation. What does that I mean is, let's say if you are using dilatometry and you are measuring volume. Okay, so with the temperature, volume versus temperature. Okay, so there will be a time where there will be change of sudden volume. Okay, so it could be entropy, volume, or enthalpy, specific volume. So if you're plotting the volume versus temperature curve, volume versus temperature curve using dilatometry, or you can using enthalpy, or what you call it, entropy. So this all you see here, SH or V, SH or V, the temperature. If you're observing the transformation in dilatometry, and here you have a melt or a liquid at particular temperature, you're getting a crystal or solid. Okay, in that case there will be a transformation temperature at which you get this transformation. Okay, you get this transition. So what does this first, second, third means? Any quantity, either V or either H or either S, if you can write it in terms of G, the first differential equation of G. Okay, if it is dou G by dou T or dou P, is V or is H or is S. Okay, the equation, if these all terms which are y-axis as a function of t, if you're plotting, okay, okay, as a function of, if G is a function of t, where you can differentiate you can differentiate dou G by dou T so that you can get a quantity of V, H or S. Okay. If that is true, then a temperature at which you're getting this first order differential equation exactly equals to V, H or S is going to tell you the first order. Why? Because the differential equation is of the first order kind. So I want to share one slide where you can see this very, very clearly. So you have to memorize this, okay? So this is just fundamental equations that you know from thermodynamics, okay? So this is the curve that I was talking about, okay? So this could be TG or this could be TM depending on what you are plotting in what conditions, okay? So if you see this transition is happening from liquid to solid, from liquid to solid at Tm. Which quantity you're measuring? VSH, okay? And what is your what is the input or what is the x-axis? Your x-axis temperature or volume or pressure. If you're measuring with respect to temperature, so you can, if G as a function of I mean you can always write no minus S dot T, right? So the first order differential equation of G becomes equals to S. First order differential equation of G becomes equals to H. First order differential equation of G becomes equals to V. Then if you're plotting V versus T or V versus P and then S versus T or H versus T, in all these conditions there will be a temperature, there will be a point where this transformation happen. That point is called, that phenomena is called melting, okay? So why melting is first order transition? Because at exactly melting temperature, at exactly a temperature, melting temperature where this transformation happens, and that temperature is a function of G, that the free energy is a function of G of first order derivative. That is the first thing. So V S H, if you plot with T or P or V, you should get a temperature where this transformation is happening, and they all are first order derivative of G. That's why they are all called first first order transition. Okay. Now the same thing VSH, if you plot with T, and you see in certain materials, okay, you see another transition, okay, another transition. If the transition is happening, okay, at a temperature, and if transition is happening at temperature, then that temperature will give you a transition, okay, indication of transition, and then transition is second order transition, okay. So that TG is second order transition. So why is that? Because the second order derivative of G, second order derivative of G. So you see here, V is first order derivative of G, S is first order derivative of G, H is first order derivative of G. Now the first derivative of V, what will happen? Dou V, and V is itself dou G. So dou, and if you replace V with dou G, it's nothing but dou square G, right? So if so, you can see here your alpha, your Cp, your K, okay. This all you see, Cp is your what? First order derivative of S, where S is itself is first order derivative of G. If you put here S equals to dou G, it will become second order derivative. So Cp is also indication of Cp versus T is also indication of second order derivative. So if you plot Cp versus, if you plot Cp versus T, a temperature, a transformation temperature you will get where there will be sudden drop of Cp, and that tells you the transition. That transition is second order because Cp is second order derivative of G, because actually it's S and S is nothing but first order derivative G, so it's overall second order derivative. So who defines a transition? I mean, what defines a transition is second order, first order? It is defined by the thermodynamic equation, whether that quantity is related with the, whether that quantity is related with the, what you call it, first order derivative of G or second order derivative of G. So simply Cp or the Cp, quantity Cp, okay. Of course, you have to go with the H, okay. Cp If you plot with T, you're always going to get a transition temperature, that is Tg, and that tells you the second order transition because it's a second order derivative of G. So that's the overall idea. So glass transition is second order transition, okay, and you have a melting transformation, melting transition is your first order transition. Okay, that's a mathematical term that is used, okay, to define this transition. Okay, so what others you can plot? Okay, so melting or vaporization, they all are first partial derivative of G, so they shows first order transition. And glass transition, and there are also some magnetic transition that are uh, 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 particularly classified as second order derivative. So these are notes from Dr. Dhara, you can get it from YouTube. Okay, just wanted to give the credit to him. So by default, your melting is going to be first order transition. Why? Because SVH with a T, you get a transition at Tm, and that is why melting is a get a transition at Tm where S, V, and H all are first order derivative of G. Okay, that's why it's called first order transition or transformation. Please remember this. Why I'm writing this is very important. Many time gate this graph has taken as a basis to form many questions, literally many questions. They can, I mean, from the same graph, they have asked every year one question and in unique ways and different ways. So this is a complete memory based question, but they can ask many concept based question as well. For example, the same, for glass, you can write something like this for a particular cooling rate, and you can also have a, you can also have a, you can also have a another glassy graph, and then they can ask you this is Tg1 and this is Tg2, and they can tell you if I increase the cooling rate, what will be impact of Tg. For example, the glassy, this is glassy, right? This is glassy. So glassy will have higher entropy, higher enthalpy as compared to crystal or not, crystalline or not. Glassy has higher enthalpy as compared to, I mean, these questions are asked in previous year gate. I'm just trying to tell. So this you can infer from this graph only, right? And this TG and every questions you can infer from the graph only. So these are this type of questions, every type of possible combinations I have given in the test series, so you guys have already practiced it. In case if they're asking completely different in unique way, just don't forget the basic. Okay, just don't forget the graph, that's it. If you draw the graph, if you see the question, if you see the option, you will be able to reach the answer. Okay, so just focus on basics, focus on the what is the fact. If you put fact in front of you, all the equation, all the formula, all the graph in front of you, you will be able to find the answer because they all are framed and derived from, these all questions are framed on that basics only. Okay, so you can find the answer. Next question is also very interesting question, but it is well known, right? So if it is if your polymer is for example, your polymer is what do you call it, uh, I mean, what is the type of chains? Monodisperse. Huh? So if your polymer or if your material is monodisperse and polydisperse, so you all know what is polydispersity index, right? So polydispersity index PDI, what does that PDI says? That PDI says that there will be broadness in all values MW, MN, and MZ. So actually, it's a new Virat, Wala, and Zazba, right? So your MN, you get first MN, then MW, then sorry MV, then MW, and then MZ, right? So this is a particular, this is the molecular weight, not this height. Okay, this weight, this horizontal distance from origin zero. If this is zero, origin zero, then this from zero to this, let's say 2000, let's say 20,000 is your MN. Then the MV will be slightly higher because it is this much, right? So it could be 22,000, 25,000. Then MZ is also higher. Okay, so this is your, not this height, this is a, of course, volume fraction. Okay, this is your mw and this is your mv, I mean mz. So you see your MW is slightly higher than Mn, right? So that means your MW by Mn is known as how, what is the ratio is known as polydispersity index, right? So this broadness, the dispersity means how dispersed the molecular weight of chains are, how big and small the variation in the chain lengths are. That is called the dispersity. Okay, the difference in the size or chain. Higher the difference in size of the chain, more will be the Mn and Mw difference, and that's why we get a broadness. Why? Because Mn is completely based on the number of chains, and Mw is completely based on how big the I mean Mn also gives you an idea of how many number of monomers are there per because that is the degree of polymerization, right? So of course you have to average it for many chains. So for many chains, again, it measures number and total weight. So Mn is based on the total number and Mw is based on the total weight. We are going to see the molecular weight, one question on molecular weight only. So we'll see the formula. But I'm trying to tell you Mw is based on the total weight and Mn is based on the total number of chains. So that is why if total weight, if you see the different size of the chains will have different weights because they have different number of mers, right? So that is why you got a different Mw, Mn difference value, okay? And it's always greater than 1. But and because of this variation in, we call it polydispersity. But if your question is monodisperse means all the chains are having the same length. All the chains are having the same length. What does that mean? A group of chains will have the same length, then another group of chains, let's say smaller group of chains, will have same length, then another group of chains will have the different length. But this group 1, this group 2, and this group 3, there are many hundred thousands of groups, okay, with similar size of chains in monodisperse. In polydisperse it's different, okay? So this is n1 number of chains with the m1's equal molecular weight, right? M1 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 M1, right? Everyone is having the same number of mers, that means same molecular weight, m1 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 m1. Okay, so total weight w1 will be n1 and m1 and n1, right? M1 and n1, because mi and ni is going to be the wi, right? So that's the idea. In case of this G2 group, let's say all are having the M2 molecular weight, M2 molecular weight, and how many numbers total as a N2. Okay, so your total, your G2 is going to be M2 into N2 is going to be W2. What I'm trying to, because all are same size, you can have same M1, I mean M1, M2, M3, all are same M2, M2, M2 only. Okay, but in actual scenario, there will be something like this, okay, something like this. So this is I mean something like this. So you can a mixture of different size of chains, but still you can categorize it with the different sizes, okay, because they are in millions billions numbers. You can write there are many, let's chain number, this chain 1 and chain 2, they seems equal size. So you group it of this length, then this and this and this seems equal size, so you group it, okay, you group it. So here you have a two numbers, and I mean let's say n1 numbers. Of course, it is one and two numbers, but I'm giving you n, because there could be many similar size chain. I'm giving n1 number, and since they have same size, so m1 size, and we got n1 and m1 as a first group. Similarly, I have another size, so another molecular weight, and I have another numbers. It's three right now, but it could be many. So I'm giving you n2 numbers. N2 m2 is another group. So you can, this polydisperse sample, polymer sample, you can group it in category n1 m1, n2 m2, n3 m3, right? N3 m3, and this is how you combined everyone. N1 m1 plus n2 m2 plus n3 m3 divided by, I mean it's all about ni by NIMI by summation of NI, that is your MN, right? And NI is MI square by NI is the MW, right? NIMI is the MW. What I'm trying to tell is this is how the polydisperse sample with different size chains are grouped in terms of N1, M1, N2, M2, all of them. And then you calculate the average, that is NIMI by NI, okay? Now in monodisperse, what does this? This is polymer. In monodisperse, all the polymer chain are same. There is no other group. There is no other group, not at all. There is no other group. So you have a, let's say, n number of chains, with each chain is having m number of molecular weight. So total Wi is going to be n into m. That's it. There is no other group with the different n1 m2. There is another group, there is n3 m3, so that you combine, you give the weighted average, that is summation of nimi by summation of ni, or summation of nimi square by summation of nimi, right? So that is why if you see this type of sample, what is the formula for your mn? What is the formula for your mn? Mn is summation of nimi by summation of ni, right?
Yes, sir.
Similarly, what will be your MW? MW will be summation of NIMI square by summation of NIMI, right? Now, this I is a group. This is the first group. This is second group. This is the third group. But your polymer is monodispersed with only with one chain length, that is having each molecular weight M, and then total number of chain is N. In that case, if you simplify this is going to be N1 M1. This is going to be N1 M1 plus N2 M2 plus N3 M3, right? And divided by N1 plus N2 plus N3, and dot many others, right? Similarly, this is the same, right? N1 M1 square plus N2 M2 square plus N3 M3 square divided by N1 M1 plus N2 M2 dot. Now there is no N1 M1 N1 N2, right? So if you put simply for this one group, it's my monodispersed polymer with m number of your M1 M2 M3 M1 M2 M3, all are same. All are same. It's just M. And your N1 N2 N3 N1 N2 N3, all are same. It's just N, right? Because they are of the same numbers. Please mute yourself. Okay, so if you put here your N1 M1, it's just N into M divided by your N, right? Yes or no? Yes or no? If you put this one monodispersed polymer, it's just N by N. Yes or no? So in that case, your molecular weight is M. Average molecular weight is M. Okay. Now in case of MW, what is that? NIMI square. So it's NM square, right? NM square by NM, right? MW, NM, right? So NM is going to cancel out. It's M, right? Your MZ is NIMI. There is a constant A as well. But if you put, I'll come to that formula. If you put this conditions there as well, you'll get the same. You'll get the same. MZ is also same, M. Okay, so what I'm trying to tell here is that since you have simplified all the groups, you make the single group with single same size chain, it becomes a monodispersed, and your molecular weight is always same. It's like, why it's coming everywhere same? For example, let's say you have 10 students, each having age of 20 years, each having age of 20 years, each having age of 20 years. What is the average weight? What is the average weight? What is the average weight? 20 years. Because if you're adding all of them and divided by the number, you'll get 20 only, right? For example, Virat Kohli scored in 1, 2, 3, 4, 5, 6, 7, 6 innings. In every inning, he scored 40 or 40 runs, 40 odd runs, or 140. Why not think positive, right? So 140 odd runs. What is the average? Average is 140. So it doesn't matter whether you are doing by number average or weight average or Z average or this, all of them will be only 140, right? That is how the monodisperse means, okay? So, and for them, the polydispersity index graph, for the polydisperse, when you have MW is new Virat, MN is, right? So MW is higher than MN. In this case, Mn is equals to Mw. What does that mean? Because the more broadness, the more is the gap between Mn and Mw. This is Mn and this is Mw. So there is a gap. The gap means this value is different and this value is different, right? So in case of monodisperse, that we usually get in where you get no termination steps. In which polymerization we have no termination step? we get star polymer or different kind of end group polymers. What is the polymerization technique? Anyone?
Anionic.
Anionic. Very good. So in that case, our graph will be something like this. This very sharp, like something like this. Now your molecular weight Mn is here and your Mw is also here. Like this is, I mean, very sharp. So you don't get broadness, right? Something like this. If this is your distribution, what is the Mn and what is your Mw? All are same, right? So that is the idea of monodispersity. That's very important. Another question is asked here based on the monodisperse in numericals. So what this is the answer, right? And I have already given these notes in the test series, and my regular students knows very well that. So this is the idea, right? So in case of in case of for synthetic polymer, your Mw is greater than Mn. Okay, so that we all know. This is greater, guys. Okay, and new Virat wala jazba. So this is typically the increasing order. But if they are equal, okay, if M and Mw all are equal, they will be considered as perfectly homogeneous. Means each molecular has the same molecular weight, and we call them monodisperse. What is a special case? What is, do you know any polymer or biopolymer? Yeah, any polymer, those are monodisperse. Yes, all the biopolymers or proteins. Okay, proteins are monodisperse, having the same length, same Ni, same Mi. Okay, so that is the idea you have to remember, please. Okay, and this is asked in gate. Now let's go to the next question. So next question is just memory based. So nitrile rubber is butadiene and acrylonitrile. Don't need to think too much here. And also the compatibilization. So in blends, I've given huge number of slides in test series. If you read carefully, you know P and PP can be compatibilized using malic anhydride grafting, right? So you have a P chains, and if you can graft malic anhydride here. Okay, so maleic anhydride has that malic anhydride. So it's a malic acid. So from that you get a if you hydrolyze malic anhydride, you will get malic acid. But you see, you got this bonding, right? Anhydride bonding, and they are available to do the bonds, right? So your polypropylene can be grafted with malic anhydride. So polypropylene grafted with malic anhydride and then PE. This is compatibilized blend. Okay, or you can say grafted copolymers, right? Grafted copolymers you are using. Huh? So for compatibilizing, because grafted PE, PP grafted malic anhydride is a graft copolymer, and this is having the same chain structure as the PE, as the PP, so they can stabilize at the interfaces, at the P and PP interface. At the interface you can put this graft copolymer, and because this copolymer has both PE component and both PP component, PP component will be easily stabilized with the PP, and PE component will be easily help to stabilize PE, so reducing the entropy. That means increasing the entropy or minimizing the delta G. That is the overall idea, or reducing the delta H. Okay, so making it negative. Okay, so that is the overall idea to make the compatibilization. Same idea is here also. So instead of malic anhydride, grafted malic anhydride, PPP grafted malic anhydride, which copolymer you're using? The block you're using, polyethylene or polypropylene. So on the interfaces, let's say this is PP micro what do you call it, micro क्या बोलते हैं, grains or domain, and this is PP in your microstructure. On the interfaces, this polyethylene block polypropylene, this you can put here. Polypropylene will help to stabilize and stay in the synergy and equilibrium with PP, and then P component will try to stabilize itself and minimize the G value. Okay, delta capital G value by maximizing the minimizing the enthalpy. That is the overall idea to get the compatibilization. So please read compatibilizing, physical compatibilizing as well as chemical compatibilizing. So they are very important, and they can be asked. So usually PS PPU is the basic concepts that everybody use. PS PPU, that is the only miscible blends that we know. They are miscible almost at 100%. Every from 0% to 100%, from 0 to 100%, what do you call it, composition, if this is PS and PPU. But in case of others, it's usually it's usually like this. So they are miscible only in this range, only in this range. This is the G curve, of course. Okay. So, and this range G is positive. So that is the case. Means most of the polymer blend, they are miscible in certain range. PSPP is miscible in all range. So all the questions are based on this. I've already given a lot of material in test series. Okay. So please revise that, and that will be more than enough. Now the dye swell phenomena. So it's actually a definition. So dye swell assumption we take, assume there is no dye swell when we calculate the blow up ratio, when we calculate the output from the extruder, when we calculate the output from the what you call it, die, okay, or the output from the injection unit, right? So I mean the molds, from molds section, or from the what you call it, different zones in the molds, okay. When it's coming from outs, when it's coming from the die, when it's coming from the when it's coming from the die to outside, the swelling effects happens. That's why the die word is here. So what does that swelling means? So if you remember the viscoelastic, if you remember the because it's viscoelastic phenomena is happening here, because it is somehow semi molten or above TG. So it will show you viscous, as well as some components are in what do you call it, solid. So they will show you the elastic, or most of the polymer shows viscoelastic. So this viscoelastic effect will be there, and in the viscoelastic effect, if you see the curve, you'll be able to understand what are the different components while giving the strain with the time. Okay, with the time, if you give the strain, because you are elongating here, the polymer that you're getting, you're elongating here, you're creating the strain. That is strain, how it responds with T. So it strains because the behavior is viscoelastic, all the component of strain, okay, whether it is instantaneous elastic or viscous retardation, or whether it is elastic recovery, all of the component will be there. This phenomena comes from the elastic recovery. So I would like to show you two notes that I have shared to you. Okay, one note is from what do you call it, the rheology, the Kelvin-Voigt model, which predicts very similar to the viscoelastic effect. There is another question that is asked on Kelvin-Voigt model. Okay, so see, they have touched similar questions, more than one questions on similar topic. That is also possible. So if you see this current slides, this is the slides that is predicted by four parameter model, and the very near one is the Voigt model, or Kelvin. The Voigt Kelvin model that gives you nearby prediction. This is the nearby prediction, where you have a increase in strain and then decrease in strain with the time. Actual effect is this. Actual in polymers, actual effect is this: when you elongate the polymer, it will have a certain instantaneous elastic strain. Then that strain will keep increasing with the time, with the, of course, increasing slope, strain rate. And then after you unload it, or remove the load, okay, remove the load, means load becomes zero. Whatever the instantaneous strain is there, that is going to recover same amount, and then remaining strain will will remove will be recovered, will be removed from the system. Okay, remaining strain will be removed from the system. What does that mean is, imagine you have a pole and two poles here. Okay, two poles or two rod or whatever, and you have not one plastic ropes. Okay, and you put one cloth here, a bit, which has a bit load, and so you get a, and this is not, this knot is very tight, there is no chance to get this any slip. So you get an instantaneous strain, uh, very small, of course I've given very high. Instantaneous, it's very tight, so instantaneous strain in the rope, okay, rope, and that you get instantaneous strain, and then slowly with the time the strain will increase, because you're constantly pulling it down. So that the strain will increase with time. That's what the creep means. It will increase with times. So let's say with the t times, your final rope has become this. So its strain has increased from 0 to this much value, okay, final strain. Now if you remove this cloth, what will happen is this cloth, of course, will try to bounce back to its original form. So whatever the instantaneous strain that you developed is going to be, so this rope will become slightly tighter, means it will go up. Why? Because that strain is recovered. After that, it will have a permanent strain. It will have a permanent strain that it has developed. Okay, it will also, if you leave it for some time, it will of course take some time. If you leave it some time, okay, I'm of course I'm not talking about thermal expansion, guys. Don't take thermal expansion or temperature in this consideration, because it's just a pure chain recovery and chain elongation. It's a rheological effect that we are discussing here. So it will recover, all the strain will recover, okay, all the strain, that the strain that is recovered is called elastic recovery. And this is the part that is responsible for die swelling. Okay, so if you see here, the if you see this Robert, I mean the RJ Crawford book. So RJ Crawford book is the best book. Okay, so only chapter 4, that the chapter which deals with the analysis of flow of polymer, okay, is the chapter that is important. Okay, if you, I mean, extruder in any flow, okay, in extruder in any flow, if you read, you have to read at any cost the analysis of polymer melt flow. Okay, this is very important. Especially the flow in extruder is very important. They ask the direct example, they ask in the gate exam, and also the basic understanding of the theory. Okay, like this strain rate versus strain rate, this in Newtonian and plastic, how they're behaving, the theory is important. Okay, of course we learn it in rheology, right? Like strain rate with this the how viscosity changes, how different parameters changes. Okay, so this we already have discussed in rheology, if you remember. But the theory is also important. Okay, theory is also important. See, this question is from WLF equation. Okay, so WLF equation, and see how shift factor based on the shift factor the viscosity is asked. So see this carry model, right? Now tell me whether this question was asked in gate or not last year. This exactly same question was asked using carry model. Okay, so they take this book, Crawford book, and they frame the questions. If they want to frame in rheology, if they want to frame in of course rheology questions are also framed from Robert Ogolle. But the polymer melt behavior problems, they always they are drafted from this Crawford book, because Crawford book is such a nice book. They gives all the mathematical expressions, so you don't need to worry about all this lengthy derivation. Okay, don't worry about this. What you need to worry is this formula. And don't worry about formula as well. Okay, don't worry about formula as well. They will give you formula. Okay, they only want you to know whether you have basic mathematical aptitude or not to solve this equation, if you parameters are given, or if you have. If you see this question, gate question, this question, direct question was asked based on this carry model. And I don't want you to kahan gaya wo model. See, this question was directly asked. The equation was given. Even you don't need to memorize the equations. Nowadays, they are giving equations formula as well. They just want, here it's just mathematics. Okay, it's not tough. You put everything and you'll get your answer. I'm just telling you. So if you read that Crawford book, at least read that polymer melt flow. You read all the. I think the IIC Bangalore professor who set up this paper, what he did is he simply opened his favorite chapter. Okay, that polymer melt analysis. He opened his favorite chapter, and then what he did is, okay, so this is my favorite chapter. I always teach in my course. Okay, let's go. What is the interesting topic that I can see? Okay, I see this typical graph. Okay, these questions are already asked last year, so let's not touch it. This is also already asked. No, let's not touch it. And then he suddenly sees this carry model, which is a simplification of predicting viscosity with the strain rate. And then he says, okay, let's give one question from here. Let's give one question from here. Then he saw no one will be memorizing this, no student. Then he said, let's give this question and give all the parameter and ask how to tell me what is my a or lambda. Okay, he has given this a as a lambda. Okay, then he went down and then he see, okay, what else I can ask. Okay, so this question can be also asked, but they will give you the equation, so it's easy, it's not difficult. Please practice this question. Okay, they will give the question as well, don't worry. You have to calculate the a value, and then you have to put a value in this carry model. That you can easily do because you know how to calculate, how to know the shifting factor from WLF equation. And then he simply goes down and then he see what else I can ask. Okay, and then he sees there is a concept called swelling, and there is a formula for swelling ratio. Okay, you don't need to worry. Remember, you don't need to worry about all this derivation. Don't memorize. Okay, just read the theory if there is like there is a theory of elastic behavior of polymer melt for viscous behavior of or melt behavior of polymer melts, that it is already given, right, using carry model or all those models. Now from the elastic behavior he framed this question: what is swelling ratio? What is swelling ratio? So it's a good example of elastic recovery. So what happens in swelling ratio? And there's a formula for swelling ratio also. Please memorize it. Okay. So it's nothing tough. This is my dye dimension. If my polymer becomes like this, so I have a different dia. Let's say D final. This is my DI initial. So my DF by D final. So DF by D initial. This is my diameter was, let's say, 5 mm, and my final extruded diameter becomes 7 mm. So what is my swelling ratio? How much it is swelled? So this bigger number divided by smaller number is your swelling ratio. Formula is not tough, but the concept behind is important. So polymer melts can can exhibit elastic, because that's why its name is called viscoelastic effect, right? It has viscous effect as well as elastic effect. Elastic effect can be modeled using spring, and viscous effect can be modeled using dashpot, that we all know, right? Many 4 parameter model as well as Kelvin-Verget model we all know. So you have an elastic. During flow they have ability to store strain energy, so they can store the strain energy. When the stresses are removed, they are going to recover. So all the strain energy is going to remove from it. Why? Because everybody wants to minimize their energy. Everybody wants to be in their minimum energy state. That's the universal law of thermodynamics, right? So this strain energy that is stored, once you remove the stress, it will remove, and that is why the strain is recovered. So strain that you got with the time, the instantaneous, so strain that you got with time, it's going to recover, right? So exponential decay is there, and this is going to predict by Kelvin-Verget model, e to the power minus t by tau. Okay, this term, so exponentially decay with the t, right? So it's given there, and so they ask this question. So that's why I'm telling, the Crawford is the best book for at least understanding the basic numericals, basic expressions, and basic behavior. At this time, you don't read everything, every expression, because expression they will give you. At least read all the theory. And I have already framed many numericals, many theory from this book in the test series as well. Okay, so let's go back and see the question. So this book is really important. I'm telling you once again, Crawford and Robert Ogle. If you're watching this video on YouTube, you please be aware. You join our test series, we'll give as many questions as possible. But still, if you're having self-study, you have to read that book. Don't go in the lengthy derivations, that will not help you. Just read, understand just solve all the examples, numerical examples. If the formula is very difficult expression, don't worry about the expression. Okay, imagine that expression is already given in your question. Now how and then it becomes only maths, right? So you don't need to worry about that. Usually nowadays they're asking only math. They are giving all the equation, all the data, and then saying solve the equation. Okay, this question is also elastic recovery, right? We all saw. Next question is thermoforming operation of semi-crystalline polymer with glass transition Tg and melting temperature Tm is carried out at temperature T. So what does that mean? That means thermoforming you're doing at what temperature? Obviously you want your material to be soft, right? So when you clamp on the female molds, so there is a thermoforming, we heat it, right? So we heat it above Tg so that it becomes viscous, right? So it becomes viscous so that once you apply the pressure or let's say vacuum, it should attach to the wall, right? So your temperature should be always greater than Tg. You cannot have more than Tm, obviously, because it will start flow, so it will not have any mechanical integrity to touch. So obviously this is option, and this is intuitive as well. I hope you all understand it. Now feedstock is cycling of the polyethylene. So I have already given the in the test series type of recyclings, okay? And in my regular batches, I have already explained each type in detail. If you read that, that will be enough to answer this question. But I've already given references videos as well. So there is a one course called recycling of polymer, and there they have explained all the type of recycling, and I have covered it in my test series as well. I have given the reference videos as well. I ask every one of you to watch it, at least know the definition of each recycling, what is their important points, what is their properties, what is their characteristic, is there any important point in every recycling. So let me open it. So these are all biodegradable polymer. Let me tell you, okay, all the polymer can be asked. If they will not ask in recycling, they will ask simply the which one of them are biodegradable. Because biodegradability is the trend right now, research trend. Everyone wants to get the same property, same synthetic property with biodegradable polymer. See, polylactic acid monomer was asked whether it is cyclic or not, right? So they will ask, okay. So the professors are very, they're not going to ask very tough question if you read all these examples that I have given to you in test series as well as regular batches. So I have already covered the syllabus. So this is the typical symbols that is important, and then this is the typically. Please pause and read this. This is a typical plastic waste sources. This is in the syllabus. It's clearly mentioned in the syllabus. Plastic waste sources. Huh? So I don't want you to remember this all data percentage, but you should know what is the major portion that is coming as a waste, whether it is organic or paper or plastic, whether it is packaging or whether it is automotive. What is the major major polluting source? And then what is the different sources of plastic waste in terms of administrative? And then you have what is the identification separation? This is in the syllabus, okay. Sorting techniques, you have a manual, automatic, combined, automatic. You have a based on hydrocyclones, hydrolysis, pyrolysis, chemical, glycolysis, all this type. And the X-ray, IR, we can use melting point, we can use, you can use flotation technique for sink float tanks. You can use for if there is a high difference in the density, you can separate the mixture of waste based on their density. So density greater than one will sink in the water, density less than one will float in the water, and then you simply उसको छान के बाहर निकाल लेते हो, right? You screen out all this floating. So that's how also we sort and separate the mixture, okay. So I've explained each and every technique in a great details, okay. This is already available in Wikipedia. This is also available in the these are all typical. You can pause and read this, okay. So I'm just giving you so that you will have very, I'm not given this all detailed descriptions in test series, but you read it, okay. From here our regular students knows this very well, okay. So you just read as a simple understanding, like what is weight sorting, what are the different types, especially types, which type of polymer can be sorted using flotation or density separation. So especially those polymer which has this difference, very high difference in density. Sorry. Okay. So this is the typical how they floats, okay. Specific gravity or density. Density is important. Higher than one and less than one is going to. So these all things have been discussed in NPTEL videos. I'm not giving this from me. I'm going to give the credits to him, the professors from IT Kharagpur, I guess. So you can read that, watch that video. But if you don't have that time, please read this. That is enough, okay. Uh, but if you're watching this at the start of your course, please watch that few lectures that is I have given. I've only given the important lectures. That's it. You see, hydrolysis, glycolysis, hydroglycolysis. If you read this, you know what is it is and why it is used in, why hydrolysis is used in, what do you call it? What is the that क्या था ना वो? क्या नाम था उस टेक्निक का in the question? Feedstock recycling. In feedstock recycling, why hydrolysis is important? If you read that, you will get, you'll understand it, okay. um, Forgive me. So these are the different type of recycling technology that is used, and in one of them is feedstock recycling. That is what asked in GATE. Okay, so this is the type that you need to remember. Each type you see to understand the conditions. In what condition, in mechanical recycling, what the condition that is applied. Okay, and in it's a feedstock. What is the condition? Pyrolysis or feedstock recycling. What we exactly do with the waste? We heat it, we generate it, we remove the gas. What exactly we do? We do hydrolysis. If your polymer is hygroscopic, if your polymer is hygroscopic, that can absorb the moisture, okay. Like for example, all the esters, okay, they can degrade, right? All the esters, mostly the biodegradable esters, uh, they can be recycled easily using hydrolysis. So in feedstock recycling, we use the hydrolysis technique. So I have given all this different type of recycling process, and this is individual. If you have to just read the points, these slides are directly taken from YouTube, so I'm nothing doing special. Okay, this is typically given the feedstock recycling. You just read it. Okay, that will be enough, and you should be able to answer the any typical questions that is asked in gate. Okay, this is a typical applications. Okay, that's it. So I wanted to share this so that you can read it later. And if you're watching, our if you're our test series students, so in the slides of your notes that I've shared to you for test series, I've given for recycling part few slides, and I've given few videos reference. You can watch that as well. Okay, if you have time. Otherwise, don't stress too much, just revise, practice the questions. Okay, uh, that's it. Next is, which of the following polymers are synthesized by ring opening polymerization? So see, the polylactic acid that I showed is the biodegradable polymer. And both polymer are given from the same slides, right? From the same slides that I just showed to it to you, right? If you see this all biodegradable polymers, you just need to know their monomers, right? And see this. So all the polymers were chosen from here: polylactic acid and polycaprolactam. Okay, so you just need to memorize these polymers. That's it, and you will be able to. I have given detailed notes in the test series notes, as well as in the answer of the test series questions as well. So I hope you are revising all of them. That will be more than enough. Okay, so this polylactic acid and polycaprolactam, this were asked. Okay, so how they are polymerized. Okay, so if you open simply search, and if you simply search and uh, Wikipedia, you will be able to see the both are cyclic. Okay, their monomer are polylactic acid. Polylactic acid can be formed from polylactide. Polylactide is a cyclic monomer, and of course polycaprolactam is also a cyclic monomer which can be opened. Okay, uh, by seeing the structure also, you should be able to know. See this O, and somehow you can connect this is somehow you can connect this, right? But you should be knowing what is their monomer. They can frame in that. I mean, every polymer you have to know the monomer, right? Otherwise, this is the basic requirement that everyone needs to have. For every polymer, you need to know the monomer. Then only you know whether that is cyclic or not, whether you can polymerize using ring opening or not. If it is cyclic, you can polymerize using ring opening, right? So that is the overall idea. But the polymer were chosen from the group of biodegradable. There are biodegradable, there are biopolymers, there are what do you call it? Natural polymers. I've given this classification in the notes as well. Okay, this is one notes. There are another notes that I've given to you all, but this is enough. Okay, just remember all the biodegradable polymers, and that's it. Next question is very interesting and not very difficult. So I've already given you all the concepts of what in the test series notes, right? In the test series notes, I have given you the concepts of where is my gate test series notes? If I'll go in the starts, um, you see in my test series notes, the very first two slides I have given the concepts how R star will choose M1. What is the rate? What is the rate of the reaction formula? What is the rate? What is the rate for this? R star choosing M1, giving you M1 star, M1 star. What is the rate, right? So I have already given you the rate equation, right? See, I have already given you for M1 star to choosing M1, I need K11 as a constant. And what is the equation? Equation is this. The rate is this, right? Rate equals to this, right? Similarly, the radical M1 start to choosing M2, I need K12. And for that, my equation rate is this. I have added both of them together to give you the total rate, right? Total rate of disappearance of M1, right? So this idea you have to just use. You just need to remember for any reaction. For example, let's say A plus B equals to, let's say constant is my K, A plus B equals to C plus D. Then what is my rate? The simple rate.
Class चलनी
Please mute yourself. Oh, suddenly he did also. Great. So rate, what is rate? Rate is, what is the rate constant K into the molar concentration of reactant A product of reactant. If it is, let's say, 2, then it will become A square. If it is, let's say, 3, then it becomes A cube. If it is just 1, then it is just A into B. This is the formula, right? We all know, right? So the kinetics is there in our syllabus, material science syllabus. So you should know basics of kinetics. Otherwise, this much is enough. What is the question given in the questions given in the test series is enough. So you just needed to remember this, okay? And that is enough. Just so what is the probability? Probability is probability of reaction this out of total is the rate of this divided by total rate. That is the definition of probability, right? So that was the idea that you needed to use. Okay, it's not rocket science. Now there's a trick here. If you don't follow that trick, or you have basic understanding of probability, you might think it as a difficult, though it was not difficult at all. Okay, so from this information that is given to you here, I can write the R1, right? I can write the R1. What is R1? The reactivity ratio. Okay, so R1 is nothing but K11 divided by K12, right? And my R2 reactivity ratio, R2 is nothing but K22 divided by K21. This is understood, right? That this we use to define whether my copolymer is what we call it, different type of copolymer we can find out, right? Yeah. So now by definition, F is given, and that F is the ratio. Remember, it's not capital F and small f that we know, because small f is the feed ratio, capital F is the ratio in the copolymer. That's not true here. Here it's simply the feed mole ratio. Instead of small f, they have given the capital F. That actually doesn't matter, okay? Because our final answer is in terms of capital F. So we just need to substitute M1 by M2 in terms of F to get the final answer. That's it. It doesn't matter whether it is capital F or small f, what is the standard books notation what they have used. But let me write. So capital F is feed mole ratio, or M1 by M2. Simply write as a mathematical terms. Okay. Now what is the probability of, what is the question? Question is, if the reactivity ratio is already given and the feed is already given, now it's saying ki the probability of reaction P2. Okay, what is the probability of reaction P2? The probability of reaction P2 is that chances of reacting M1 star radical with M2. Chances of reacting M1 star radical with M2. Means, let's say M1 is traveling on a path. M1 star is on the path of moksha. Okay, it wants to get moksha by reacting with any monomer. But because this is such an unstable high energy state, it wants to get its moksha, means equilibrium state. How it starts its journey at point A, it got M1 star. Okay, I'm sorry, really sorry, means M1 M2 all are in the path. Let's say here you have a, this is a diversion in a path. There is a monomer M1 here. Okay, now, and there is a diversion at the same point M2 here. Why? Because at any point during reaction, the probability of being M1 present near radical, and the probability of M2 present near radical is same. It's a 50-50, right? Because every M1, M2 monomer both are given the same temperature, same diffusion. Okay, so mobility, the monomers mobility, because viscosity of the whole reaction chamber is almost same, because we are maintaining the same temperature. So movement of M1 and M2 is not restricted, it's not biased, right? So they are free to refuse. So M1 is here, M2 is here, whether M1 or M2 will go and diffuse there, or the probability of being M1 present here is 50%, probability of being M2 is 50%. So the diversion is 50-50, right? It can, your M1 star choosing M1 is 50%, M1 is choosing M2 is 50%. That's a simple idea, right? That's why I have given the half. Okay, now in the later stage, there is another path. There is another path of M2 star. M2 star also wants to get the moksha. M2 star wants to react with M1, M2, whatever, to become the to transfer that radical, right? So it also get M1 and M2 at some path, right? Right? So So I'm asking, what is the probability of P2, right? That means what is the chances of M1 star going through the path and reacting with M1 and M2? That means reacting with M1 and M2. So our overall sample space is only these two. We don't need to worry about this P3 and P4. So when I was solving this question, I was at, I mean, we always write, na, and what is probability? Probability is the favorable case divided by total case, total number of cases, right? So when we write total in the denominator, I was adding the rate equation, rate for rate, क्या बोलते हैं, rate value of this, all of them together in the denominator. What is the rate? Rate here, rate is K11, K11, and then M1 star, then M1. What is the rate value? Rate of this reaction. What is the rate of this reaction? It's a K, K12, and K12 and M1 star and M2, right? So the favorable cases means the probability of P2 is rate of this reaction divided by rate of this reaction, rate of this reaction, because we want to calculate for this, divided by total. Total is rate of this plus the rate of this. It's very simple question, but plus rate of this, that is the total rate. But what I was doing is I was taking total considering all four reactions. I'll tell you why all four is not correct. What is the rate of reaction for the second P1 is this, right? So K1, K11, M1 star, and then M1. That's it. This you have to solve this. The probability of P2 is this only. You have to solve this. Of course, you have to substitute this, and this here to get the final answer. We'll see the derivation. It's not a difficult task, but this is the idea, right? But what if you are choosing to give all the rate of P1, rate of P2, rate of P3, rate of P4, all sum as a total? That I was trying in my first attempt. Why that's wrong? That's wrong because we are asked to calculate chances of M1 star to react M1 and M2. I'm really sorry. Chances of M1 star reacting with, कहाँ गया यार? I mean P2, right? Solving P2. So chances of M1 star reacting with M2. So it's a fixed, the path is fixed. We are talking about only M1 star, not M2 star, right? In this two reaction, M2 star is the reaction, right? So when it's asking probability of getting M1 star reacting with M2, means probability of getting, chance of getting M1 star. That is the question, right? So only M1 star reaction should be considered because in the path, M1 star is only traveling. There's no point of getting M2 star, right? That's a very important thing that you have to understand, okay? Because P2, probability of P2 is saying that M1 star reacting with M2. That means M1 star can react with M2 as well and M1 as well. Both chances are possible, right? So that's why in total only M1 star reacting with M2, M1 star reacting with M1. Only this should be given. There's no point of getting M2 star because M2 star is not there in the P2 reaction. Okay, that is the overall idea. I hope you all understood. Now rest is just the mathematics. If you want to show it, if you want me to show it, it's just the fraction of reaction. And I mean my my P of P2 is going to be rate of P2 reaction divided by rate of P1 plus rate of P2. Of course, I'm not revising P3, P3, because we are calculating for chances of reacting M1 star radical with M2. We call it the reaction P2, right? So chances of reacting M1 is such. That's why we are focused on P2, P1, P2, because in both, if M1 can react with P2, there is a chances of getting M1 reacting with M2. Then there is a chance of getting reacting M1 with P1 as well. That's the total condition of P1, P2 or M1, M2 is there. Okay. And now, so rate of P2. So you can always write K12 M1 star M2. Why? Because your M1 star reacting with M2 giving rise to, right? सही है ना? M1 star. Okay. What is P2? M1 star reacting with M1. क्या लिख रहा हूँ मैं? M1 with M1 is P1 ना, सही तो है. Okay, so this is simple. This divided by total. So K12 M1 star M2 plus K11 M1 star M1. Okay, and now you have to just substitute it. So you see M1 star is here, right? M1 star is here, M1 star is here, M1 star is here. So and M2 is here, right? So you divide M1 star, M2 star, and both numerator denominator. Why? Because we want to make in terms of ratio, because our M1 by M2 ratio is F, right? So we want to get our answer in terms of F, and also we want to get K11 by K12, something like that, right? Because your R1 is K11 by K12, right? And R2 is K22 by K21, right? So we want to get in terms of R1. So you have to remove all the M1, M2 in terms of F. So we have to do it. If you divide this M1 star M2 in both numerator and numerator, so this is going to be same. So they are going to cancel out. And in the denominator, if you divide M1 star M2, so they are going to cancel out. And here, if you divide M1 star, okay, so M1 star is going to cancel, M1, M2 is there, right? That's what I wanted, right? So I can get my answer K12 divided by K12 plus K11, and M1 by M2 is F. Now I want to get in terms of R1, right? My final option is in terms of R1, R1F, and 1, right? So I want in the denominator 1 or R1, right? 1 or R1 or R2. That's my task, right? In numerator, I want to get either 1 or R1 or R2. That's it, right? So I can get R1, R2. So how can I get R1 and R2 or 1, whatever? So I transfer this to this side. Same idea. So 1 divided by K12 by K12, right? And plus K11 by K12 into F. And you see K12 by K12 is 1. So our final answer is 1 divided by 1 plus K11 by K12 is R1. So R1 into F. And that is our probability of P2. See, it's not tough. The math is not tough at all. If you know, you have to take 2 in the denominator. And if you know what is the rate, what is the probability meaning? Probability is probability is rate of reaction of particular interest, that for which we want to calculate probability, divided by total rate. That is a favorable case by total case. No, that's the overall meaning of probability. I hope you all understood it. It seems so bulky, so difficult, but actually it's not. Okay, but of course it's tricky, because you need to understand what is P2. What is P2? P2 is only about M1 star, not the P2 is only about M1 star, not the M2 star. So there's no point taking this in the denominator of total cases. So our final answer should be, I think, B, right? 1 by 1 plus R1 plus X, something like that. Now this is just memory, so I don't want to spare a lot of time. You just need to memorize. If you want to have a lot of polymer technology notes, okay, if you're watching this YouTube video, you just join the Telegram channel and seek for the help. Okay, I'll be there to help you out, and I'll give all the list of polymer technology, that all the additives that is important for gate. And if you remember that much or practice that much, that is enough. I already shared that notes in the test series, right? You all have already got it, the polymer technology, the list that is important, the notes, the additives, and all those notes. Yes or no? Anybody? You all have already got it, no? In the additional PDFs that I've shared. I hope every one of you. Okay. So it's there in the drive. Okay, please revise it. Some things are very obvious, right? Something like soybean oil is of course plasticizer, right? And the dibutylene malate, this dibutylene, so DBT, so it's a height stabilizer, of course. So some things are, if you fix someone, something will automatically fix in this option. So sometimes you don't need to memorize everything. Here this is also very obvious, that if you know only one answer, you can get the, you don't need to finalize. So in my second attempt of gate, I got only 20 minutes to solve all the polymer science paper. Let me be honest with you, only 20 minutes, because I was trying to solve each material science question. So I was not being practical. I was thinking, like, since I teach, I should be solving, getting 35 out of 35. So at what cost? I spend almost 95% of the time, 90%. So I got only 20%, 20 minutes time to solve polymer science. And in that case, uh, this MCQs, what I did is, I I just tried to see what is the unique in all four options. What is unique in all four options? I see everywhere Q1, Q1, Q2, Q3, Q1, right? So either two, either one, or either three, right? So if I can know the exact answer of Q, like Q3 is not repeated everywhere, right? Of course, Q1 is repeated, then I have to know the exact answer of S, right? Or P. So I just needed to know the one answer. That's it. I don't need to check everything. So a dielectric strength is nothing but the voltage at which it will break down, right? So voltage will come, volt will come. So dielectric strength is volt. So if you remember R4, R4 is unique, I think. Yes. See, R3, R3, R2. No one is having R4. So this is your answer. You don't need to check for any other things, okay? But of course, I will advise you remember units for everything, right? So I hope you all know. If you don't know, please let me know. I will tell you the formula using what you can calculate the units. Okay, you don't need to memorize units. You should memorize the formula. For example, Pascal seconds. It's a tau equals to gamma dot. Yeah, tau equals to gamma dot eta, right? So no, tau equals to gamma dot dv by dx, right? Eta dot, I'm really sorry. Eta into dv by dx, or tau equals to eta gamma dot strain rate, right? So if from here eta you can find out, because eta is your what? Pascal. And I mean, tau is Pascal, eta is just eta, and dv is meter per second by meter, because ds is meter. Meter is going to cancel out. It's a Pascal second, right? Similarly, your complex viscosity, impact strength. It's of course impact strength is always joule per meter. Okay, means energy absorbed per unit thickness. It's from definition. And flexural strength. It's the formula of flexural strength is quite complex. I'm not able to memorize it. What is that? FLQ by, what is that formula for flexural? एक तो है BDQ, right? What is formula for flexible strength? Anyone? Okay, so it's there in the calister, and I used to memorize it.
3FL by
Sorry,
3FL
yes.
2 bit square.
3FL by 2 BD square.
Can you please repeat it?
3FL by divided by 2 BD square.
हाँ, 3FL. हाँ, मतलब that's it. Or in terms of not BD, in terms of another also you can find out, no? It is circular. In terms of R also, please memorize. Okay. So this is a rectangular cross section. So from here you can easily find out, right? So it's a Newton, right? It's a Newton, right? And then meter, right? And B is just meter, and meter is square, right? So of course you have to I mean, of course, Newton per meter square, that is megapascal. Newton per mm square, of course. And this is the strength is megapascal. That's also no brainer. So you can find out all this from the definition. Okay, so please, definition and the formula. So please please be ready to apply any formula to find out units. Okay, if you're not able to memorize units. Okay, some units you need to memorize. MFI, MW. So if you remember the definition of MFI, I have already given this type of question a lot in test series. And see, that question was asked in gate question, and still 10% of my students were not able to solve it when I did survey last time. So that means they didn't solve the test series question honestly. If they would have practiced only each question for 3 times in test series, these questions are just nothing. Just with the tip of finger, they would be able to solve it. So what is MFI? MFI is the what is the ECMF MFI machine or the equipment, testing equipment. What we do is we use a plunger, and then we apply a force, and we push the polymer. Okay, we heat it and we make it melt, and then we push it. Okay, at the standard conditions, standard load, and we have a container here, and then this polymer starts coming here. Molten polymer start coming here, and we have a stopwatch. Okay, and the moment we start collecting this polymer, molten polymer here, and we start the stopwatch. In 10 minutes, whatever the amount of molten polymer that we have collected, will wait it will wait it. And if you see, let's say it's coming, let's say 40 gram. Okay, then 40 gram per 10 minute. I mean, 40 gram per 10 minute. So our MFI is 40. Okay. So how much amount of polymer you have collected per 10 minute is your MFI. So what does this signify? This signifies how fast the polymer is flowing. So it says the flow behavior of polymer. It's important because you're going to use it in injection molding, in extrusion molding, in blow molding, in compression molding, in roto molding. So there are many types. In every molding, you need certain strain rate or viscosity or flow behavior, right? So that's why polymers are graded based on their MFI and molecular weight and viscosity. So they are graded like this sample is injection grade. The grade is injection grade. What does this injection grade means? The injection grade means it has certain strain rate that it can develop if it is molten, then certain viscosity it can develop when it is molten, a certain MFI it can develop. So it's very difficult to tell ki, what is the MFI value for injection grade material and what is the MFI value for extrusion. Exact value it's very difficult, but qualitatively you can tell, right? In what kind of processing we need high flow rate, injection or extrusion or low viscosity. Okay, we'll come to the viscosity later, because that this question is based on viscosity and flow rate and molecular weight. So see, this viscosity is decided by molecular weight. This is very simple. Higher molecular weight, higher number of chains, more entanglement, more viscous, more viscosity. Again, I'm repeating: higher molecular weight, bigger chains, more entanglement, more viscous, more thicker, more slower flow, right? Higher molecular weight, higher viscosity. This is the common sense that you should have. I am not going to teach it, right? But given that this you already know that your molecular weight is directly proportional to viscosity, and viscosity is directly proportional to molecular weight. So if you know the viscosity, you know the molecular weight, of course. So you cannot use high molecular weight where you high molecular weight polymer where you need higher flow or very low viscosity. So in injection and extrusion, in which type of processing we need lower viscosity? Anyone?
Extrusion.
Why? And why not injection? Why do you think in injection you have a injects calco na? Injects calco. This is the order of what is this order? Anyone who has learned my notes?
Shear rate.
What is this order?
Shear rate. Increasing shear rate.
Yes, shear rate or strain rate, right? Shear rate. So where you need high shear? Come on, guys.
Injection molding.
Where you need highest shear rate? Injection. Then so in the injection, you need to fill at very intricate small corner of mold, or your mold could be very complex shape, right? Like say you want to make titli. Sorry, forgive me my drawings, huh? I'm making good drawing, huh? So you're making, let's say, butterfly. So see how complex this shape is. Every corner of the mold you have to send the melt, right? So you need very low viscosity, very high shear rate, right? Yes or no? Arey bhai, what is the relation of size, shear rate and viscosity? What is for, of course, we are assuming the polymer melt, that is Newtonian. What is the behavior? With shear rate, viscosity will be. Come on, guys, you have learned rheology. Tell me.
Directly proportional.
भी मार खाओगे तुम.
Linear.
Viscosity doesn't change with
Linear.
the shear rate. Then you have one graph this and one graph this. Arey yaar, come on, guys. Okay, now if I want to plot the actual polymer behaves like this. So here it's a constant. Uh, it's a constant. Means eta is gamma dot to power 0. It's a constant, of course. Eta naught, of course. And then it start following the power law. With shear rate, it start decreasing. Huh? So higher shear rate, lower. Higher shear rate, lower. You know, higher shear rate, lower viscosity, right? So viscosity is lower, more thinner the liquid is, more easily it can flow, right? In the क्या बोलते हैं, intricate structure of the mold, right? So why I'm telling this? Because I want to make you feel the flow behavior that is required for different processing techniques, okay, so that you can solve the question of shear rate, viscosity, mfi, molecular weight. All the questions are interrelated, you don't need to learn differently, okay? So you can grade the polymer, whether the polymer is injection grade or extrusion grade. What is the required feature? What is the requirement for being injection grade? What is the requirement for being extrusion grade? What is the mfi requirement for injection grade? So this mfi is used for grading polymers for processing, right? So what does that mfi mean? Mfi means how faster the polymer flow, of course molten polymer, okay, that will give you the higher mfi from this definition, right? Higher mfi, okay. So what, it's obvious that higher the molecular weight, more viscosity, more thicker, very in 10 minutes very less amount of polymer collected, very less amount of polymer collected, less value, means from 40 it becomes 10, that means less mfi. So inversely proportional. Higher viscosity, higher molecular weight. So molecular weight is nothing but you can replace with viscosity. Means higher viscosity, more thicker, less amount collected, less mfi. So it's obvious if you know what is mfi testing is and what does. So what is the unit of mfi? What is the unit of mfi?
Gram per 10 minute.
Yes, it's very unique units. This is the only unit where you have a number in the unit. Okay. So you guys need to be very careful, huh? They can frame any question, but this was very easy question. Okay. If you are my student, this is the most easiest question. Okay. Because I give the feel about how you can analyze each testing and each behavior. Okay. Next question I've already framed the question based on this, but in a different manner. I have framed in terms of birefringence. Do you remember any question on birefringence from the test series? Anyone? Hello? Anyone? Do you remember any question given in the test series from birefringence? Are yes or no bolo na?
Yes, sir.
हाँ,
The
so if you
required
remember the
difference in the
birefringence,
testing.
what is the birefringence? Birefringence is, and actually there is a chapter in my graduation, chain orientation in polymer physics. There was a chain orientation. It is one major topic section. Whole section is on chain orientation, and top subject was polymer physics. And that time I read Gedde. That is the most difficult book, but it has more amount information that is given. In the polymer physics, you learn the what is called it. What do you learn? the root mean square end-to-end distance, है ना? Radius of gyration, and all those polymer solutions, their behavior, the perturb state, unperturbed state, right? The typical solutions, miscibility, the chi factor, like solubility parameter chi, and the osmometry, viscosity. We have all learned that in polymer solutions, right? In polymer physics. So this chain orientation is one major topic. In that chain orientation, we have a many type of orientation: uniaxial orientation, biaxial orientation, right? So uniaxial orientation means, uniaxial orientation, I'll ask one question. I have a three processing, okay, because they can be asking gate, huh? So three, there is a three processing techniques. One processing technique is called spinning, fiber spinning, and one is called, of course, let's take extrusion, film extrusion, and what else you can take? Yeah, you can take 3D, like injection molding. So injection molding mostly will give you 3D product, right? Yes or no, guys? Tell me yes or no. Injection molding will give you mostly 3D product, right? Because you have a mold, and in mold you have a shape, right? So it depending on the shape, it fills and give you 3D. In fiber spinning, mostly you get a fiber, that is 1D product. In film extrusion, you get a film, that is, I'm assuming the thickness is very less, okay? Or you can think of all the chains on the surface at micron level thickness, that will become 2D, right? Now tell me, what will be the chain orientation, of course, in terms of uniaxial, biaxial, and triaxial? Tell me. I'm giving you orientation at the left hand side, match of the following, and orientation in right hand side, match of the following. I'm giving you option: one uniaxial orientation, biaxial orientation, triaxial orientation, and I'm giving you fiber spinning. I'm giving you injection molded product. I'm giving you film extruded product. Okay, film with very thin thickness. Okay, now you have to match it. Tell me what kind of orientation you get in what kind of anyone unmute and just tell. I don't want you to spend much time, please. We have questions to go, because numericals are not. It doesn't worth to spend much time because they are direct. Anyone, please?
uniaxial में spinning है
Yes, and
and film extrusion में biaxial.
yes, and for injection 3D,
The
because I
remaining
told you 1D, 2D, 3D, then it becomes easy, right? I shouldn't have given you the options of 1D, 2D, 3D, not giving you the understanding of 1D, 2D, 3D, and then I would have given you directly fiber spinning product from fiber spinning product from film extrusion product. But film extrusion, biaxial. Spinning, I mean, you can easily figure it out, huh? Because you all are brilliant students, right? So what I'm trying to tell you here is, orientation is very important in terms of optical properties, and one of the optical phenomena is called birefringence. It's actually very major topic in engineering physics, right? That you have learned engineering physics. We use tourmaline crystal or quartz crystal. In tourmaline crystal, you have different uh, planes, right, which refract differently. This is one plane in tourmaline crystal. So let's say your coming light is this, it will reflect differently, and you might have another crystal planes, they will reflect differently. So because of that, you have a different refractive index, and because in different direction you get different refractive index, n1 and n2. Okay, and because of that, you find the birefringence, means different color in they look different in different color if you're looking in polarized microscope with slightly cross polarized. What is crossed? Crossed means you are blocking all the lights in certain direction, and you're allowing lights in certain direction. That is cross polarized. If you're using cross polarized microscope, you'll get the different color. And if you search birefringence in Wikipedia, Google, you will see different colorful polymer crystal growth that is happening. So so even one of the very important crystals that gives birefringence is that gives very different colors in polarized cross polarized microscope is what is that crystal which is look like this? What is this crystal? Come on, guys.
Steroid.
Spherulite, yeah. So spherulite is if you zoom this, if you zoom this special part, and of course there will be amorphous chains here. So if you zoom this part, you'll get very high dense crystalline structure. If you zoom this part, of course you'll get very high dense crystalline structure like packed, folded chain packed. We call it crystalline form. Here, the if you put the light, if you put the light in this direction, okay, in this direction, it will not able to penetrate, or very few light will come out. So velocity of the light is different here. And if you put in this direction, okay, in this direction, uh, so so what I'm trying to tell is, if you're putting light in different direction, every direction the speed of light will be different. If the speed of light is different, because packing is different, right? So it's easiest way to tell you is, the simplest version of this is, let's say this is my chain, okay, and now I have this direction light coming, and I have this direction light coming, okay. So this is called birefringence that I'm going to tell you. So if you're putting this light, it's very difficult. The speed of light in this direction will be low because they are packed, right? So speed of light is very low in this, let's say direction 2. And of course this is 1 and this is 2. 1 is in the direction of chain and 2 is in the direction of transverse direction, okay. And here you have a light p1 which is will be higher. So what is n is c by v? See, if velocity is higher, of course n1 v1, n2 and v2. If velocity is higher, v1 has velocity higher. If velocity is higher, n1 will be lower, right? And if velocity is higher, n2 will be, if velocity is low, n2 will be higher. So there will be difference in refractive index. The difference is called birefringence. This quantity is called birefringence. And because of that, speed, and the same thing is why the speed becomes lower in this direction. Anyone, please? Why this speed becomes lower in this direction? Hmm? Anyone? Come on, guys.
So chain does not pass light to
So what the
and
phenomena happen?
density
What's the
due
optical
to
phenomena that happens?
dense form.
What is that?
So dense
अरे
ज्यादा
यार, तुमने मेरा ऑप्टिकल स्लाइड पढ़ा है कि नहीं पढ़ा है? इफ यू हैव रेड इट, डोंट टेल मी द सिक्स स्टैंडर्ड स्टूडेंट्स आंसर, ओके? छह साल का बच्चा भी बता देगा सर यहाँ बहुत भरा हुआ है. टेल मी द phenomena, optical phenomena that happens if light rays on, if light falls on a surface, what happens? If scattering happens, right?
yes sir.
Or refraction happens, or either refraction happens, or absorption
Transmission.
happens, right? So here one of the reason is scattering, because your chain is like something like this, right? Got my point? So light is scattering. There is a area space. There is a numerical. There is a formula that I have given you in the notes based on the optical properties. Means whether light, how much is the light scattering, or how much is the refraction. There is a refractivity. There is a reflectivity in the material science also. The intensity, the light intensity that is going to change with respect to observation, the exponential decay formula. All this please memorize, okay? Okay. So what is happening is, here in biaxial chain orientation, okay, I gave the biaxial orientation only this example. So high clarity. Why is that high clarity? Why is the high clarity? Because if you have a, I mean, one of the observation because of the orientation is what? Variation in the refractive index. Means birefringence. Means difference in the refractive index. This is only in two normal directions. You can take in many directions, right? So this is in two normal direction. We call it birefringence is reduced. Why? If it is uni orientation, this object, this is uniaxial orientation. Why it is uniaxial? Because all chains are oriented in the same direction that we get in the fibers. Okay, why I did give you the examples of our orientation? Because I wanted to give this. Okay, I forgot. I miss. I just mistracked myself. So in fiber spinning, we get the fiber like this. In the fiber, you see the most of the chains are oriented in the fiber direction. That's why they have very high elastic modulus, very high stiffness, okay, and very high tensile properties, very high yield strength properties, okay. In even in a longitudinal direction or fiber direction, but they have very low properties in the transverse direction, because all chains are not oriented in transverse direction, okay. Very poor property in transverse direction, so we call this property as anisotropy. Isotropy means iso means equal, tropy means all direction equal. This is anisotropic nature, okay. But this you are overcoming by, so same is true here, all the chains are oriented in the same direction, so you have a uniaxial orientation. Here you get very high birefringence, okay. But this you can fix it with, let's say you're just weaving, woven matrix. So you are, this fiber is woven in this direction, chains are also in this direction oriented. What is this now? 90-degree cross ply that we use in term is composite, right? Now it's same everywhere, right? Even though it's just one chain thick, like it's the same everywhere, right? You don't get partiality now. So you have same velocity in this direction, same velocity in this direction, because you don't have any biased or any specific orientation. We call it biaxial orientation. In one direction, there is no one single orientation. It's a orientation in both directions, biaxial orientation. Now you don't see specific, very different in light speed in two direction. Light speed in two direction is same, and that is why there is no difference in N1 and N2. That means birefringence is almost zero. If almost zero, there is no, what do you call? First option is correct, decrease in variation. And second option is, of course, scattering, because that is how the light, the thin film or polymer film becomes opaque or what you call it, translucent. Why it happens? Because of scattering. We have already learned this in optical property, right? So I hope you all, I mean, it's not, I mean, this is quite tricky, but if you have solved my test series question and if you have understood the what you call it, main SAR of that explanation, you know, okay, what is the variation in refractive index, that is delta n, and that is birefringence, and that is coming because of the orientation in one direction. If you have orientation in both direction, you don't need to worry about this, right? And of course, this is the obvious answer that you can give. Okay, now next question is very simple. You remember kasa by saka, right? So your kasa is in numerator and saka is in denominator. You put rho, then you think, sir, this is in specific viscosity. Why you writing in density? No, no, dear, it is in this density only. Why? Because Vc is 1 by rho c. Or if Vc is this, then your rho c will be 1 by Vc. That is 1 by 0.989 into. And don't tell me you don't know 1 by rho c is 1 by Vc. Because it's specific. Specific means mass is 1. Specific mass is 1. That's why density is mass by volume. So specific when you write, this m will become 1. Okay. So that's obvious. Okay. So you can find out rho c from 1 by Vc. You can find out rho a from 1 by Va. Similarly, you can find out, this is sample. So you can find out rho s with the 1 by 1 by rho 1 by Vs, right? You find out every and you just put, you'll get your answer. Okay, it's very obvious, and don't worry about the derivation and everything. This is very important. Usually they give, usually they don't give. If they don't give, you take this standard kasa by saka. If they give, then you have to be very careful. Based on mass fraction, you are going to get volume or density, specific volume or density, because both are same, just reciprocal of each one of them. Okay, and if they're telling based on volume, okay, then you are going to write in terms of mass. Okay, then you don't kasa, by Saka, you don't write this, the factor. You just write rho S minus rho A and rho C minus rho A. This in terms of enthalpy also. Okay. So I hope you all have solved this type of numerical in test series. Okay. So you remember, you practice that. Okay. There's a fine difference, but usually they don't ask other than this by mass fraction. So the Kasa by Saka, which is given, the formula given in the calister, that works everywhere. Okay. You don't need to worry about that. Now, the glass transit temperature, oh my God, this is the Florifoxy question that you can use. So 1 by W, 1 by TGAB equals to WA by TGA plus WB by TGB. Remember, T is in Kelvin. If you're thinking to put in degree Celsius, you are messed up, okay? You are dead, okay? By solution. So use this. So it's a 50-50. So 0.5, your WA is 0.5, WB is 0.5, assuming A is my PS or PP, what, it doesn't matter. You put TGA, you convert into Kelvin, and you put, you'll get your answer. Okay, it's not a rocket science. Tell me if you're not able to get the answer. I'll give the solution. I'll send you to solution. If you're watching the YouTube video, just text me in Telegram. Okay, text to the admin of that group, huh? Not anyone. Next is also so simple. Why I don't understand why my students didn't get more than 60 marks. One of my students got 59 marks, but he should achieve. I mean, the material science. If he's solved honestly my test series question, he can leave 5 marks only. He can easily achieve 30 marks in material, and seeing this question label only that this is complex, because I know the ratio of rate is probability, but even I first attempt I was giving this also in the denominator, na? So I assume okay, this you can leave, right? Do you think any other question is there where you need to leave? Really really you need to leave? No way. These all questions are directly from test series. Okay. So you don't need to leave it, only except this question. And other than that, you really think this is going to be leaved? No way. You might have, I mean, there is another question that is tricky. Yeah, this one is tricky. This one is tricky. Okay. So you, of course, if you've learned my regular batch or test series, it's not tricky at all. I'll give you the explanation. It's not tricky for me, but for others it may be. So you can leave 4 marks. You would have easily obtained 31 marks here and 30 marks here. And in the aptitude, you just need to solve only aptitude math, no engineering math, no English. Okay. Don't answer English aptitude if you don't know the exact answer and correct answer and you are 100% sure. Don't do tukka or obviousness. Don't go by obviousness. Obviously this looks obvious. Don't go by obvious. You should remember that answer by any textbook or logic behind that answer from any textbook, like Rain and Martin book for grammar. If you remember that logic of that English grammar, then only you give the answer. Or if you remember the exact antonym, synonym, or some kind of a phrase or something like that, if there is a will, there is a way. Huh? That question was asked in one of the gate question. There is a will, there is a way. If you remember that quote, you can write way. So you're 100% sure you write the aptitude English question. Otherwise, you leave it. Okay. If you can score only 6 to 7 marks from aptitude, see how many score you're getting. So two questions you can easily, 2 to 3 questions you can easily leave in metal polymer. No worry, okay? Since you're in the last phase of preparation, don't worry about that. Solve all the easy questions, okay? You could have easily scored more than 60 marks. Yeah, 65, 67, 70 marks, okay? If you have a good aptitude as well. Forget about 40 marks, but some of the students might get panicked and they leave it, okay? So see this question, 126, what is there? VM is there. VM is given. I mean, really, this question deserves in 2 marks. I mean, this is VF. Of course, if it is not given, it is assumed that total is 1. So this is 0.3, but it is given, it's okay. EM is given, but only you have to remember the unit. It's very important. But here unit is also same everywhere. And fiber. And can you remember the material science question where the EM was given 6.9 and EF was given 69? Here EM was given 3.5 and EF was given 350. Do you see the similarity? Eh? What is the similarity? Similarity is same professor set up this paper. to make this calculation very easy. Okay, so 3.5, 350, it's just a factor of 10 or 100. 6.9 or 69. Oh my god, this is a question from material science. Can you imagine? Same formula, same data given in the 2 marks in both paper. Can you get this kind of simple paper ever in your life? Never. I've never seen the this is the most easiest paper ever sit in GATE exam history of XE. Okay, I can declare that. But this the next paper could be even more easier. Okay, because they are focusing more on concept rather than memory. So this is everything is given. They are asking to calculate a longitudinal composite even. So even is EFVF plus EMVM, and you'll get your answer. That's it. This is not tricky if you remember the concept of P. So let's write what is given. So polyamide 66 is prepared by concentration of this many moles. So your Na or Nb, whatever you say, 0.08. Hexamethylene, my A is HMDA. Please remember. And point this many. Of course, this could not be same, because if it is same, R is 1, right? It is 1:1. 0.08 mole. If this is same, then it is a what kind of reaction? 1:1. Then what is my Xn formula? बताओ जी. 1 by 1 minus P, right? This would have been so easy to solve. I only need to calculate P. But there is a trick. At the end of the polymerization reaction, the reaction product contains this many moles of B. My B is carboxylic acid, of course, adipic acid. So this many mole of what? Functional group or monomer? So it's saying 0.08 mole of functional group. So I'm really sorry, monomer, HMDA. So the functional group will be 2 into 0.08 mole. This number is mole of functional group. Functional group reacted. This is the Na is a mole of functional groups, not monomer. Why I have multiplied 2? Because each monomer has 2 functional groups, right? So your hexamethylenediamine has 2 NH2. And your क्या दूसरा है? Adipic acid has 2 COH. So each monomer has 2 functional groups. So each mole have 2 mole functional group, right? Let's say your monomer is 1 mole. That means how many molecules of this monomer? 6.023 into 10 power 23 molecules, right? Molecules or monomer. Then how many functional group? Each monomer has 2 functional groups. So you have to multiply 2 into 6.023 into 10 power 23 functional groups. This many functional groups is mole. Right? This many number is 1 mole, no? So that is 2 mole, right? So 1 mole of monomer gives 2 mole of functional group. That is basic calculation understanding that you all should have. And when we calculate R, when you calculate R, that is the molar ratio, R equals to either Na by Nb or Nb by Na. In what case it will be Na by Nb? In what case it will be Nb by Na? Anyone? Please unmute and tell. Come on, guys, tell me.
Always less than 1.
Less than or equal to? It could be equal, no? Same molar.
Yes.
So
Yes.
R is less than equals to 1. So in this case, Nb is greater than Na or smaller than Na to get less than 1. This is always true. This is convention. You have to follow this, okay? Because all derivation is done based on this only. Tell me, Nb is less than Na. Then you have to write Nb. Means your numerator should be always a smaller number. That's the obvious general idea you should have. Then only the whole fraction will become less than 1. For example, let's say Na is 4. Then your Nb should be less than 4. Like let's say 3. Then only it will come less than 1, right? For this, your Na should be smaller. Your numerator should be smaller than denominator. That's the idea. But what is this Nb and Na? They are the mole of functional groups. How many moles of functional groups? B, functional group A, where this is my HMDA, no? A. HMDA functional groups. Functional groups is my A, and AA functional group is my B. Let me write more carefully. This is wrong. A is my A represent NH2 functional group, and B represent COOH functional group. This is more accurate, but I'm writing in terms of this so that I can correlate all the data that is given, right? Okay, that is the one thing that you have to remember. Okay, so if this is, so Na is 2 into this and Nb is 2 into this, but unfortunately it says ki when reaction was done and product was analyzed using which technique, using what technique I can know whether there is a unreacted monomer or not. Anyone? What is the characterization technique I should use to check whether I have all the monomers utilized in the reaction or not? Come on, guys. What is the chemical
N,
characterization you will do? Come on, guys. I've already taught it.
NMR,
Eh?
NMR,
NMR is very advanced. But of course, it's there. And are very basic you can do in your chemistry lab, yaar. Using both only
GPB,
beaker. Eh? Using only beaker, guys. Come on. Arey yaar. That technique is used to calculate molecular weight as well. What is that technique? To know what functional group is there available in the reaction.
In group analysis.
Yes. The moment told you functional group, you jump to end group. But with monomer, you're not jumping. That monomer is also having functional group. No. So end group analysis. So we do the titration technique. I've already taught it in test series, but I don't know whether you guys remember it or not. End group analysis. So let's say in the remaining, how many are left in the COH? What is that? COH left, no? This many unreacted COH, right? So if acid is remained, what we'll do? We'll add alcohol, right? Yes or no? We'll add alcohol. And the acid and alcohol will form ester, right? And that ester will have certain pH. In that pH, which color of the indicator which indicator will give color in that pH, will add that indicator as well. The moment this reaction will form, we see a pink color. That is what we used to do in titration. No, the moment this ester form, we get a different color. Okay, and using that different color, we know, oh, reaction is happening. That means there was some monomer available. And how much monomer? That we do by calculating how much OH I added. How much OH I added. That many OH will give you how many molecule of OH I added. With that molecule, I know how many each molecule have each OH, right? That many OH is utilized. That I know that many COH was available. That many COH, each COH, I know what is the molecular weight. I will multiply that molecular weight with that many COH. It's 100, and then I know the total molecular weight. That is how we calculate the molecular weight using end group analysis. I hope you all understand. I've already given this question in the test series, okay? And also the detailed explanation video solution in the drive as well. I hope you all remember it. So that is the idea. Now see, if it is just same number, if there is not unreacted, then it is just 1:1. This you apply, you'll get your answer. But this piece would be given in the question. But you see, this P is not given in the question. Okay. And of course, this Na and B is not same. See, this B group is remaining. So initially it was 0.08 minus 0.002. Okay. What is the value that you'll get? What is the value that you'll get? कोई calculator open करो, नहीं तो I need my solution. Forgive me. Yeah, I got my solution. I'll directly put the okay. So this value that you will get is how much? 0.158 moles. Of course, you have to multiply by 2, right? That many functional groups were actually reacted. So your NB was this many and your Na was this many. This is not true because some of this many reacted. So you know your R, and you have N1, not 1:1, but different Na and B. So you get a 0.158 into 2 divided by this 2 into 0.08. So you get a 0.9875 R. So you know your Xn. What is Xn? What is Xn? What is Xn? Come on, guys. 1 plus R by 1 plus R minus 2 PR. But you for your m naught. Of course, this is not m naught. M naught is this is the monomer molecular weight. You have to divide by 2 because two monomers are involved. That is the standard we use always, right? We always take the average molecular weight of residue that we use for xn. So your mn is xn into m naught, where m naught is 113. So you already have m naught, okay? And what they are asking calculate mn. So you need to calculate x naught. To calculate xn naught, xn. To calculate xn, you have already r. You don't know p. Come on, guys. What is the definition of p? If you know number of moles reacted, what is the definition of p? What is definition of p? Any one of you? Come on. I want answer. What is p is extent of reaction, right? Degree of conversion, right? So what is the formula for degree of conversion, or what is the definition of degree of conversion or extent of reaction? If you can calculate that because you know moles, right? You'll get your answer within fraction of second. Okay. So you just need P. You have R. You can calculate Xn. You can put here. You'll get your Mn. That's it. So how to calculate P? What is a P? If you don't know what is P, how will we? This is if you see the Dr. Dhara's video, which is available in NPTEL YouTube. Please watch that. In Dr. Dhara's video, he starts with taking spheres as a monomer, start reacting and defining what is P and what is Xn, dP. Come on, guys. Okay, let me show his slides. Okay, let me show his slides. Because if you don't understand that basic, understanding of P and understanding of yes, if you don't understand the understanding of P, then you're in a deep trouble, right? So what is P? So if you see Dr. Dhara's notes, and the same I always taught in my regular batch as well, he says P is fraction of functional group reacted. Simple. I mean, how many moles reacted divided by what was the initial. So as per our understanding, whether this is for one monomer or two monomer. Come on, guys. So you see this, what he has taken. He has taken how many monomers? Total number of monomers, 12. So he is taking both monomer 1 and monomer 2. Right? Blue and green. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the typical monomers, and they are not reacted. So you take total functional group. So N naught is the total number of functional group at the start of the reaction, and reacted is the number of functional groups, total functional groups after reaction. Means reacted number of functional groups after reaction. That's it. So 0 reactor, 0 by 12 is your P. That's your basic understanding, right? People also write in terms of N naught by N by N naught, and C naught by minus C by C naught. It's the same actually. It's the same. Initially, how many of them are initially there, right? In initial total number of functional, including both monomer, guys. Come on. The adipic acid as well as hexamethylenediamine. Now you can easily solve and calculate P if you know this detailed understanding. So he gave this much hard work his PhD student did to draw all these spheres, do all the calculation. If you don't understand this, that means it's very difficult for you. Okay, memorizing direct formula can help you. Okay, it helped no in most of the questions. So you can solve at least 330 marks question, but to solve difficult question, you need to know this understanding. Okay. So N naught is the initial total number of functional groups that we all know from AA and BB, means both type of functional groups. And N is the at time T, what is the remaining non-reacted? Non-reacted, I'm telling you, this is reacted. This is N naught is initial number of monomers that is not reacted. N is the final number of monomer that is not reacted. This is the number at T, not reacted. This is the initial number that is not reacted. Okay. So this is in terms of not reacted. This is in terms of how many reacted after reaction. And this is the initial number of course, non-reacted. So number of moles is nothing but mole per liter, because you have to just divide by volume. So volume, let's say V volume, and V volume. Divide V in both numerator and denominator. It doesn't matter. This becomes C naught minus C by C naught. Because V is everywhere same in the same reaction chamber, it's cancelled out. That's why N naught C naught is same. So whether that concentration is molar concentration like 2 mole per liter, right? You can also put here, or whether it is only mole, you can also put here, okay? Because liter is just 1 or V, because it's just ratio, okay? Now, so this is the understanding that you need to develop. What is P? And he has given really nice. Now, the another excerpt that that one uses, if your, let's say, 1:1 reaction ratios, molar ratio, then your you all know xn equals to 1/1 minus P, right? Yes or no, right? So in that case, uh, in that case, 1 minus P is 1 by xn, right? So here you can write this, right? P equals to n naught minus n by n naught. I'm just giving you how he calculated xn equals to n naught by n. Okay. If this is only true, if this it is 1:1, I'm just trying to tell you. Otherwise, don't use this blindly n naught by n formula. And because you know, sir has already taught me what is the n naught and n. I know the most. I will directly put and I'll directly get my answer. dp xn is n naught by n, but it's true only for 1:1. I'll show you how. So p is equals to n naught minus n by n naught. Okay. And so 1 minus P will be, what did I do? What did I do? Do. I just I just subtracted 1. अरे यार कैसे करेंगे 1 minus P? अरे you have to split this. So P equals to n naught minus n naught minus n by n naught. This becomes 1. So P equals to 1 minus n by n naught. That means 1 minus P becomes n by n naught. So 1 by 1 minus P becomes reciprocal of this, n naught by n naught. And 1 by 1 minus P is nothing but xn from the 1:1 ratio, right? That is why you can directly use n naught by n, means how many was the initial number of total number of moles from both monomer, if it is two monomers involved, divided by how many are remaining non-reacted at the end of the reaction. Okay, non-reacted, I'm telling you, not reacted, non-reacted. Of course, this is also non-reacted only, initial. So you can get directly xn that he was using this. Actually, this is derived based on 1 by 1 minus P, right? This is not true if the Na and Nb are different, right? That in our numerical, in gate numerical. So you cannot use this, but you can take this concept as a help to calculate the P. I hope you all understood, right? So this is there. And I've also shared the slides where in test series slides also there, where this formula is given n reacted by n naught. It's there. I don't want to open. Okay. So I hope you have. Now it's I lost all my calculation, but not a worry. We calculated R, we calculated NB, right? We calculated NB, and that NB was initial number of moles 0.08, sorry, 0.08 multiplied by 2 minus this many moles of monomers are not reacted, right? Unreacted groups. Oh my god, this is so tricky, guys. Come on. If you use 0.002 moles of monomer not reacted, then what you will have to subtract? 2 into 0.002, because this is just moles of monomer. So each monomer has 2, so 2 you have to multiply. But it's saying this is the mole of groups, functional group that is not reacted. So you have to just subtract this many, because this you got total number of functional groups, because this is the mole of adipic acid, subtracted by this, then you get 0.158 moles. Okay. And now it's simple. Na is 2 into 0.08, that means 0.16 moles. This is the, what is this calculation known? What is this calculation? This is completely reacted. And we in our definition, Nb by Na or Na by Nb, they are reacted or non-reacted? They are always reacted functional groups. Remember, guys, they are always reacted number of functional groups. So we calculated that. Which one is smaller? Nb is smaller. So we calculated that and we got 0.158 divided by 0.16, and that we got 0.9875. Okay, this is R and this is NaNb. Now, what is P? P is N reacted by N naught. Don't use N naught by N as a direct action, okay? Or you can write N minus N, N naught minus N divided by, you cannot N minus N naught minus N divided by N. This also tells you the reacted only, right? How many was initially? available non-reacted. At the last, how many are non-reacted? You subtract, you get the reacted. Okay. So how many are reacted? Functional groups. Functional groups. So in case of my HMDA, whole everything is reacted, right? So 0.08 into 2, 0.16 functional groups, not the more, mer. 0.16 from A, that is my NH2. Okay. And my B is COH. How many reacted? So this is remaining, right? So if you subtract this from point, you cannot subtract this from 0.008. See, this was actually tricky. You cannot subtract 0.002 from directly from 0.08 because zero point 0 was given for adipic, because this is the mole for whole acid, whole monomer, and this is the mole only for groups. So you have to multiply by 2 and then subtract this. That is 0.158. This many are reacted, right? So your 0.158 was reacted because this is remaining. No, you have to subtract from here and divided by total. What was total? What was total? So 0.08 into 2, 0.08 into 2, right? Initially to point, I mean, sorry, 0.08 into 2 into 2, that is from the adipic. 0.08 into 2, we want functional group, not the monomer. So 0.16, that is point, that is 0.36, 0.32 plus 0.16. And if you see, you got 0.993750. If you don't understand the concept, I mean, there are two concepts tested. One concept is in your R, these are only functional group, not mer. Okay. Then why? I mean, you might be thinking, sir, in my whole life, in whole test series, I use directly the moles of mer. And now you're saying functional group. Actually, actually, if it is given that 10 moles of adipic acid and 20 moles of HMDA is given in the start of the reaction, and your P is, let's say, 0.99, calculate XN. एक बात बताओ, your R will be 10 by 20, it's okay to write. Because if you multiply by 2 here to make it functional group, if you multiply by 2 here to make it functional, does it matter here? No, because everything is reacted. So it's 2 is just a factor. You can cancel it out. So you think it doesn't matter if it is you're writing monomer moles or whether you're writing functional groups moles. Okay? Because everything is reacted. But if everything is not reacted, then it changes. Because number of reacted is only functional group, not monomer. If something is remaining, then you have to calculate very sincerely. You have to convert every mole of monomer into functional group, and then you have to subtract and do calculation. Okay. Now, if you have P here, if you have P here, if you have R here, if you have a M naught here, 113, don't use 2 to 6 because M naught is always average residue of monomer. 2 monomer is involved, so divide by 2. And if you put in the simple expression 1 plus R by 1 plus R minus 2PR, you'll be able to get your answer. I got my answer, you'll be also able to get the answer. That was a bit tricky, but if you understand the concept like me, like I have just taught you, remember this. You won't be, this concept will help you a lot if they will ask similar question. This similar, exactly same question I have given you in my test series. The only variation here is that the fractions are not given, whether it is mole fraction or weight fraction. What percentage of mixture is mixed is not given. Other than that, we have solved many questions based on this in our regular batches worksheet exercise as well as in test series. So there is a small trick here to calculate the fractions. Other than that, I don't think it is very tough nut to to crack. So if you see here a monodisperse polymer sample of this and this, so you have A. So remember this type of mixture type of problem when you're calculating the lot, means molecular weight, average molecular weight. Remember to use in terms of groups, that I taught. Now this is this many big, this is this one another group. Okay, so this group have three features. One is Ni, right? Another is Mi, and another is, what is another? Anyone please? What is the weight? Ni into Mi, Wi. Three feature must be known, or some of them should be known to use in the solution. Another lot, What is Ni? Ni means how many number, right? How many number? For example, let's say this is N1. If it is monodisperse, every chain has same molecular weights. Every chain is M1, M1, M1. So your molecular weight is M1, right? And then here, let's say your how many chains? Here it is looking 4, but I will not write 4. I will write N2. And how many? Each chain has how what molecular weight? Let's say M2, because they are monodisperse. They will have same size. So M2. And then if you multiply Ni N1 into M1, you will get W1. You say, sir, W1 is gram. Then how will you get gram when you are dealing with mole? Of course, yeah, N is mole. Mole multiplied by M is gram per mole. If I multiply mole is cancelled out, I'll get W1. So actually Wi is Ni into Mi. And total summation of Wi, total individual W1, W2, W2, if you add all the weight, we get the total weight. We get the total weight. So if you apply the summation here, you have to apply summation here as well. Okay. So I hope you understand this many small things to, they will help you to memorize formula, because memorizing expression is difficult. Okay. Okay. Now, so you need to have Wi as well. So that is a product of N1, M1. So even if you don't write, it's okay, but let's write here W1, N2, M2, and W2. This is the three things you have to notice what is given. So in this sample, M1 is given, right? M1 is given 10,000 because each polymer chain is having M1. And same, same disperse with another. So M2, that is 50,000. Okay. Now when you're mixing it, this is, let's say, group A, I would write 1 and 2 because it's easy to write N1 and N1, M1, something like that, 1 and 2. So if you add 1 plus 2, okay, so your total, so here you don't know what is your W1, here you don't know what is your W2, here you don't know what is your N1, here you don't know what is your N2, right? We need N1, M1, MW, NMW. This is the three variation in all type of chains. Every molecular distribution is solved. You have to focus only these three, okay? But this M1, M2 is given, W1, W2 is not given. In that way, you don't know what is the ratio here, in what ratio they are mixed. If it is written 1:1, then it's simply 0.5 weight fraction. Small w is weight fraction, guys. 0.5 weight fraction of first and 0.5 weight fraction of second. If it is 1:2 ratio mixed by weight, 1:2 by weight, then what is the ratio? 1 divided by दोनों का sum. First divided by sum of both. That is first W1, first weight fraction, and W2 will be, because I am calculating for second divided by total. So 2 divided by 3, that is my W2. Why I'm writing, why I need W1, W1? Because I can calculate my molecular weight, right? So your MW is summation of Wi Mi, if you remember the formula. That is small W1 M1 plus small W2 M2. So if I know my W1 W2, if I know my W1 W M1 M2 is already given, I can get my answer, right? So my only goal is to calculate W1 W2. What is W1? What is W1? W1 is weight, capital W, weight, individual weight of group 1. I'm talking about total weight, W1 divided by, means this group total weight. Okay, W1, that is NIMI. Okay, divided by W1 divided by the total weight. That is the weight fraction of 1. And weight fraction of 2 is similarly capital W. Individual weight of species 2 is ith species or 2 type of second group divided by total W. This is, but I don't know the individual weight W1, W2, right? If I don't know individual weight W1 and W2, let me write in black color. W1 and W2, I cannot know the fraction. It's, remember, it's an individual weight, not fraction. Fraction is the weight of that component divided by total. Okay. So, and also I don't know N1, N2. So I also cannot calculate the mole fraction. So your mole fraction is small n, or people also write X. X1 is capital N1 by total N. Total N is all N1 plus N2 plus N3, all of them. And X2 is capital N2 by capital N. Then you can know the Mn, because Mn is summation of Xi Mi, right? So So here x1 m1 plus x2 m2. So if you know the 1:1 ratio by mole, then it is 0.5, 0.5, x1 0.5 and x2 0.5, right? So if ratio is given, if individual weight or mole is given, you can calculate that. Individual weight or individual number of moles is given, you can calculate that. Molar ratio in which they are mixed, or weight ratio in this way. But here it is not given. That's what I want to tell, because it is there in the formula. We need that. Okay. It is not there. Okay. So we need that. Whether we need that or not, we see. Okay. So that is what. So in your mixture, what is given is the total weight. कहाँ गया भैया? The total mass. So W1 and plus W2. Sorry, it is capital W because small w is fraction. Okay. That is my convention. You can use whatever you want. Okay. So W1 and plus W2 is given as 1 kg or 1000 gram. Here W1 W2 is not given, but total is given. Okay. And not, they are not talking about what is my total N1 and N2, or also total M1 plus M2. Must N1 N2, there is no information about N1. There is no, see, M1 M2. Why M1 M2 is not given? Because they will combine and they will give you the average M. Depending on N1 N2 and M1 M2, they will combine, they will combine and they will give you, right? But N1 plus N2, something should be given, no? Oh yeah, total number of moles, total number of moles. So individual N1 N2 is not given. When they combined, N1 plus N2 is given. Total number of moles of polymer is 0.04 in the mixture. So N1 plus N2 is 0.04. They are not given what is individual N1. They're not given N2. But if you combine in the mixture, they become 0.04. So you cannot tell half. It's never written. कहीं नहीं लिखा है कि 1:1 ratio है, right? In by mole or weight. Half कैसे बोलेंगे? We don't know. Okay. M1 M2 is also not given. Others given. It's if M1 M2, this same M1 M2 will go in the mixture, no, and give you the average M, because we have different molecular. We want to make the average, right? So in the mixture, to calculate Mn, we don't have M1 plus M2 in the mixture, because they will mix. They will give you the average Mn or Mw, the average M, by using what? N and M. By using N and M of both individual component combined together, they will give the average. That is what the meaning, no, of average of two different entity, right? Okay. So our target is to first remove this mesh, right? Because my habit is to solve everything on the PDF. Okay, I think this looks cool, huh? Okay, so our target is to calculate. What is the question? Question is to calculate Mn, right? So calculate Mn, and this is the information that is given. No N1 given, no N2 given, M1 is given, M2 is given, no W1, no W2, but sum of W1, W2 is given, sum of N1, N2 is given. Now, if you see my formula list, I will show after this solution, because I don't want to lose this all, what you call it, drawing. Huh? So please bear with me. So if you see all the formula, actually that is the right way to see in front of your formula and use the common sense, which formula I should use. Actually, in your GATE exam also, you will do the same thing. You'll write all the formula first. So I will write all the formula, whether it's asked weight average or number average. Weight average it's asked. I will write all the formula that I know. I will write all the formula that I know, so that I use the brain key which formula I should use. So it's a summation of Wi Mi. If I know W1, W2, I'm happy. And fortunately, my W1 plus W2 is given. So there's a hint. There is a hint that I can calculate the fraction, because this W1 plus total weight is given. No, this total weight is given. So it's a hint that if I can know what is my W1, I can divide W1 by total and get my fraction. If I know what is my W2, I can divide W2 by total, I can get the fraction. That is W1 by M1 plus W2 by small w, W2 by M2. Why? Because M1, M2, I already know. I just need to know W1, W2. That is one formula. Another formula is, I don't think that will help. Another formula is summation of Ni square by summation of, by seeing the formula, it is not going to help you, because you don't know N1, N2, right? In this formula, you need N1, N2, no? N1 square, N1, MO1 square, and plus. Do you know how to expand this, right? If you don't know, it's very dangerous. Ni mi square by summation of Ni mi, sorry. Square will not be there in numerator. So you should know how to expand it. Then only you can apply, no? So this is N1 M1 square plus N2. If there is only 2 involved, you can write up to N, and N1 M1 plus N2. Of course, this is not going to help you because you don't have N1 N2. You have total N1 plus N2. That is also a hint. But you need to know what is individual N1, individual N2. Okay. So that is our time. Either you find out what is individual N1, N2, then you can find out the, you can put here simply N1, N2, you can calculate. Then you can put N1, M1 square, all this, and you can solve, right? Or you can also write in terms of, yeah, this is it. Yeah, this is, I think you don't need to think for any other formula. Okay, no need to complex. So how to calculate individual weight fraction or individual N1, N2? Individual N1, N2, it make me feel. So tell me, any one of you, please use your common sense and tell me at this moment. I know my total N1, N2, total mole. That means I know mole. I'm writing this with capital letter. I know total mole. I know total weight. I know total weight. Can anyone tell how mole and weight are connected? If you can see how mole and weight are connected, you can attempt calculating W1, W2 or N1, N2. You
मोल
can
होता है
calculate.
वेट बाय मोलिकुलर वेट ना.
Yes, very good. So you know कि somehow these two are connected. I know कि number of mole N1 is weight by molecular weight, W1 by molecular weight M. This I know, right? Similarly, my N2 is W2 by M2. Can I use this two equation to solve NW1, W2? Of course, yes. How? Because you have given N1 plus N2 equals to 0.002. You just need to substitute this W1 by M1 at the place of N1 and this W2 by M2 at the place of W2, N2. That's it. And you make a equation. Right? And amazing. So I thought a lot of time. I mean, it's I'm telling you honestly, this is not very easy to spot. Huh? I struggled a bit because it's very different. So you have one equation, N1 plus N2 equals to 0.04, N1 equals to W1 by M1. M1, let me write M1 given, na? 10,000. 10,000 and plus W1 by 10,000 plus N2 is W2 by 50,000 equals to 0.04. This is one that type of question, okay, where unless you know, unless you write it, you won't see it. It's a different thing, different ball of the. I mean, different thing if if you play chess. If you play chess without playing it, you can visualize it. So that's the benefit of playing chess, and that's what I do always. Every day I play at least one game of chess. I don't know whether I play how many blunders I do, but I play every day chess. How? Without moving, can you visualize after moving what will happen? How the position will change? Okay. So similarly, without putting, can you visualize it in your mind? Okay, N1 M2 equals to 2. Can I put N equals to weight by molecular? So W1 here it will come, here W2 will come, so I will get a equation W1 W2. I have another equation of W1 W2, so I have a two unknown two equation. Oh my god, I can solve this equation. Right? So that is a visualization that you can do. But if you don't play chess, you have to write it. So you don't in the gate exam, you write it. It doesn't matter how you write it. Every equation that you try to write it, you'll figure it out. Huh? So by multiplying 50,000 across whole equation, I'll get 10,000 will be and 10,000 will be cancelled out by 5 times. So it becomes 5W1, and 50,000 will cancel out with 50,000. It will become W2 equals to 0.05. And this W1, W2 already one equation is given, right? So W1 plus W2 equals to 1,000 gram. Of course, I have to multiply 50,000 here as well because I multiplied 50,000 across whole equation. So 50,000 multiplied by 0.04, it should come 2,000. Okay, now I will just need to subtract. So minus, 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 this is cancelled out. 5W1 minus 1W1, 4W1 equals to 1,000. Come on, guys, you got your W1. That is 250 gram. And what is W2? Because total is 1,000. W2 is 750 gram. So what is my weight fraction of 1? Weight by total weight. So 250 by total weight. Total weight is 1,000. That is 0.25. And what is my W2? And you might think, sir, can I use this formula N1 M2 by calculating N1 by putting my W in this equation? I mean, in this equation, if you put W1, right? And if you put W2, you can calculate N1 N2, no? And then you can put N1 N2 because M1 M2 is given. You can calculate that also. But simplest is because you calculated W, you can calculate that simply the weight fraction 0.25 and 0.75. Now you simply apply here. So 0.25 multiplied by I forgot what is 1 and what is 2. What is 1? 1 is this, na? 10,000. So 10,000 and plus 0.75 into 50,000 and you'll get your answer of 40,000. So see, it's very interesting to see that you have to first know how to draw this drawing. And wherever you solve every mixture of the formula, okay, please use this N1, M1, W1, N2, M2, W2. If there is 3, N3, M3, and W3, then in the mixture, if there is sum is given, sum is right, or if you directly Mn is given, you write. And here in ratio, you write which ratio is given so that I can figure out if it is by weight, then you can figure out what is my W1, what is my W2 from the ratio. Or if it is an equal proportion, then you simply 1 is to 1, that means 0.5, 0.5. How did I know? 1 divided by 1 plus 1, 2. I hope you know this, okay? If you don't know, please tell me. So you have to write ratio here so that you can figure it out, and then you definitely will be able to get the answer, okay? This is the overall approach that I gave you. I think we have reached to a final. Okay, so this is just a the Carnegie. Oh, there is another one. Oh my god. So this is just simple mathematics, guys. So this carry model that I saw in the Crawford book, you don't need to memorize this. You just need to feel this and you'll get your answer. So I did the simple math. I'll put everything and I got my answer. I'll tell you what is given and how to plot, and please solve by your own. I'm not going to spend much time because it's a pure math. I don't think why they asked. Maybe they asked to make us realize that we should read Crawford, right? So yeah. So simply the idea here is if there is two different gamma dot is given, gamma dot 1 and gamma dot 2, of course in second, remember, then you can write eta 1 and eta 2 because eta is directly function of gamma dot, right? So eta 1 equals to eta naught 1 plus lambda. Gamma 1 is 1, so I write just 1. I'm sorry, lambda into gamma dot is 1, so lambda is square. N is 0.4 minus 1, that is 0.6, right? 0.6 by 2 minus 0.3, so I can write minus 0.3. This is for eta 1. Similarly, I can write for eta 2. Of course, eta naught is also given 15, so let me write 15 here. 15. And similarly, eta 2, 15, 1 plus. And then our gamma dot is 10 to the power 2. Sorry, 10 power कितना है? 100 ना? So 10 power 2. So 10 power, so it's lambda into 10 to the power 2 whole square, that is lambda square 10 to the power 4, right? So it's 10 to the power 4 into lambda square to the power minus 0.3. If you divide it, right? If you divide it, so you see this power is same, so you can write simplified version. This power can go as a whole, right? And you can write interior form. I hope you understand this much mathematics. Arey yaar, if x by x to the power n and y to the power n, then I can write x by y equals whole to the power n. This is under basic power law, okay? So now I can, why I did that? Why I did that? Because eta 1 and eta 2 is given. If you increase this, the viscosity decreases by factor of 10. This is very interesting. When initial is 1 and you become 2, means in 1 you have 1 second inverse, and in 2 you have 100 second inverse. The value from 1 to 2 you go, it reduced by 10 times. But if you assume it was 100, or let's say it was 1000, it becomes 100. 10 times. How did you know? This divided by this. So if this is eta 1 and this is eta 2, then eta 1 by eta 2 is given 10. This is actually the intuition that I always use. If I don't understand, oh my God, whether it is eta 1, eta 2, what is that? I will take simple number as an example. Simple number. Like I'll take, if it was 100, it become 10. Then only 10 time reduce, no? So how will I get 10 here? Actually, ये 10 match कर रहा है, इसलिए I took 1100. So from 1000 it becomes hundreds. How did I get 10? 10 given by higher divided by lower. So eta 1 divided by eta 2. Okay. So this type of exercise you should do in your mind, or on your paper. Don't mind. Okay. So that you know eta 1 by eta 2 is given, right? By 10. Eta 1 by eta 2 is given as 10. So you can write here 10, right? So you have a 10 here. So let me write here. Let me, अरे यार. So you can write here, this implies 10, मतलब ये वाला part equals to this, right? Now this power can come here. Actually you can make it positive by reversing this order. That I usually do, because positive के साथ handle करना मेरे लिए easy है. I feel easy to deal with powers if powers are positive. So let me reverse this. X by y to the power minus n has, I can write y by x to the power n, right? This minus will become plus. So I can write 1 plus 10 power 4 lambda square by 1 plus lambda square and whole to the power 0.3. This is more easy for me. Now this 0.3, when it will come this side, it will become 1 by 0.3. That's the basic understanding that you all should know. Like if it is y equals to x to the power n, so if I'm writing x and transforming this n to this side, it will become 1 by n. So y base, this n will become 1 by n. Okay, this is the idea, power law that you have to use here. So this will become 10 to the power 1 by 0.3. 0.3 is what? So 0.3 is 3 by 10. So it will become 10 by 3, right? So this you can find out from the what do you call it? This you can find out from the calculator. And using calculator, I figured out that this value is nothing but इतना होगा, जो भी होगा यार. And then you transfer this, it will become lambda square form. So if you transfer this to left hand side, the form of the equation will become very simple. Form of the equation will become 1 plus, I think this will become 4.64 into 10 to the power 10 minus 4, I think. If you multiply this to this side, so yeah, whatever. So if you solve this, you'll get something like this. 1 plus lambda square equals to 4.64 into 10 power minus 4 and plus 4.64 in 64 lambda square, right? So this lambda square you bring together. So your final equation will be lambda square equals to 0.274484, right? And now this square will become root. And remember, they have given in the question that lambda, every parameter is positive. Every parameter is positive. So your answer will come plus minus 0.5239. You have to answer the positive number. Okay, this is your answer, 0.52. Okay. So it's not actually, it's just math यार. मतलब ठीक है, मतलब this kind of question shouldn't be asked. Actually, ask इसलिए करते हैं because some questions are tricky, you know. They wanted to make it easy so that more research student can go to IIC Bangalore, right? Because those IIC professors are, I mean, they think like you need to know the basics and concepts. I don't know on your brilliant aptitude, okay? But ठीक है. This question is so easy if you understand, if you know the concepts. The way I taught, I've already given this type of question in test series, okay? Many questions, okay? And this is this you should know that very big terms are used, like mark, I mean the Huggins equation, mark having constant, blah blah blah. But actually, what is Huggins equation? So Huggins equation is nothing but your intrinsic viscosity. Please, if you're watching this and you are still there with me, you can memorize this formula, okay? So K hyphen This I have given in the branching and the polymer solution notes, right? Eta square into C, where C is the polymer solution, of course, gram per centimeter cube you can write, and eta is the centimeter cube per gram, if I'm not wrong. Yes, centimeter cube per gram, right? And eta is specific. Please remember these units. These units are very important. So unit is centimeter cube per gram. This whole quantity. Okay. Now, uh, so what is the unit of eta specific here? If eta is specific by C equals to centimeter cube by gram, then eta is this C is what? Gram per centimeter, right? So eta is specific by gram per centimeter cube equals to centimeter cube by gram. Then centimeter cube by gram multiplied by centimeter cube by gram. That is giving centimeter to the power 6 by gram square. Is it correct? No, it's a reverse. No, sorry, ये उल्टा हो जाएगा. So in this way, gram per centimeter cube. So it's a cancelled out. So eta specific is just a unitless quantity because it's a ratio. What is the ratio? It's a ratio of, come on guys. Eta specific is a ratio of how much time taken by solution divided by how much time taken by, actually that is relative, no? Eta relative is how much time taken by solution to pass through a pipe column divided by how much time solvent took. That will take the how much is the relative viscosity. I think relative viscosity minus 1 is eta specific, right? Am I right? Anyone please?
Yes, sir. Yes.
Yes, sir. So इसका मतलब if relative is just how much time solvent took by, अरे यार क्या लिख रहा हूं मैं, how much time, so by passing through this tube. This is a typical testing that we do to find out relative. These are very, actually these all quantities should be tested in the experiment in your lab, then it's very easy to memorize. So eta relative is how much time the solution took, because if it is very thick, very high viscosity, it will take very large time, right? So how much time solution take divided by solvent is liquid like water, it will quickly come down, right? How much time solvent is taking. So usually it's greater than 1, right? If unless until you're mixing something with the solvent that it becomes even more thinner, that usually not possible. So and then eta relative minus 1. So if there is, this is minute by minute, it's just no unit. So this is why this is a no unit. That is why you should remember the units, guys. Please remember the unit, even though here unit is not required. Everything is set in such a way that you don't need to play with unit. Let me be simple with you, but you should remember the unit. Sometime in previous year GATE exam, I think, right? I have given the one question based on the unit only. Many one of you blundered that. Okay, so let's go. So if this is Y, okay, and this is C, okay, and this is M, okay, and if this C is X, then this is just a linear equation where C is your intercept, X is on your x-axis, Y is on your y-axis. So you see eta is specific by C, you can put on y-axis, and your x is nothing but C. So C you can put in your x-axis. So the intercept means this value is your intrinsic viscosity. Oh my goodness. So this is your intrinsic viscosity for polymer 1. And this is your intrinsic viscosity for polymer 2. Simple, guys. Come on. You don't need to worry about M. But let me tell you, higher the K value, more is the branching. Okay. So this K constant tells you about branching. But here, if you know, so it's asking but for both it's 0.5 is given, and then it's telling ki, what it's telling, what it's asking, niche hai kya? It's asking ki MV1 by MV2. Oh my God, really? You want to ask this? MV1 by MV2. What is MV? What is Mark-Having equation? What is Mark-Having equation, guys? Come on. Mark-Having equation says ki K MV to the power A is your intrinsic viscosity. So if it is 1, this is 1. If it is 2, it is 2. Come on here. This shouldn't be asked. This is actually, you guys should be scoring like this. अगर ऐसा पेपर आएगा तो तुम लोग फाड़ दोगे. Okay, just practice the test series question at least by 3 times. I don't want you to practice anything else, and believe me, you can perform better than any time. Okay, so KMV1 MV2. So you want MV1 by MV2. So just divide this equation, because I know my eta 1, I know my eta 2, 25 and 40, right? So this is eta 1 is 25 by 40, and K is cancelled out. This is MV1 by MV2 to the power A. A is 0.5. This will go and it will become 1 by 0.5. That is nothing but 2. So 25 by 40 is MB1 by MB2. Khatam. Tata. Bye bye. And you'll get your answer. Okay. So do you think really that if you understand the concept, oh my god, abhi aur question hai kya? Hey, yeah. Come on. This is also very simple. Uh, if you remember the Kelvin-Voigt model, and if you remember the equation, let me show my notes. My notes, because I don't remember the equation. Being honest with you, the equation I can derive if I'm giving the exam like you guys, and if I don't remember the formula, believe me or not, I will be able to derive it, because I know the constitutive equation, I know the graph. Okay. Polymer science lecture 1, of course, this polymer technology इसमें नहीं होगा, characterization of polymer week 7. uh, just let me pause the video. If you see this test series notes that I have already given you here, this is typical the Kelvin-Voigt model, right? And this is a constitutive equation that includes key one ring, one spring is there, and one dashpot is there. Dashpot has the what is tau equals to eta gamma dot, right? Or eta d epsilon by dt, right? Or d gamma, jo likhna hai likho. This I can put, because tau is the stress. This I can put here. That means here. And here sigma equals to E epsilon. I can put here, and then I can put the condition in it. I can put the condition in it. What is the condition? Means what experiment you are talking about. Let's say strain with time. That is a creep experiment. How strain is changing with time. Simply strain is changing with time like this. Huh? Primary stage, and then secondary stage, that is almost in equilibrium, and then the tertiary stage. But we are not going in this stage in the creep, we are only going up to this, and then we are unloading. So there's a recovery I can predict. Okay. So uh, so actually it is not like this. Actual in polymer, it is instantaneous, and then it goes like this, then you recover the instantaneous strain, and then it recovers the elastic recovery that it does. Actually it is this actual material, but this Voigt Kelvin model predict the almost very close to the actual polymer deformation phenomena. This model or this equation actually predict the very similar graph. That's why Voigt Kelvin model is very good for creep prediction. Okay, that's why they ask this question. Okay, so because it is very close to the actual polymer behavior of creep behavior. Okay, so you can put the, if sigma is constant, epsilon changes with time, so I can put sigma becomes sigma naught, and this becomes epsilon by t, and then I can integrate. I can integrate with the t. I can integrate with t, because I can shift this dt to this side, and then I can integrate. I can get the answer using the conditions epsilon. When t is 0, epsilon is 0. When t is t, final t, it will become epsilon t. I can put, I'll get answer. But you don't need to derive. Of course, you don't need to use that Bernoulli equation. Just simply remember this. Actually, you remember this graph now. You don't need to remember this as well. How? Because you have an initial slope, right? Or initial instantaneous strain, right? That is, so sigma equals to E epsilon, right? So your epsilon will become sigma naught by E. Initial. So you put initial, and then you're subtracting how much? How much? This much. That sigma naught by E is factored with the negative exponential factor e to the power minus t by tau. This sigma naught by E is now factored, means reduced by how many times? E to the minus negative power, means it is decreasing. If you combine both of them, right? Because you have subtract, no? This minus whatever this is strain minus this is strain, that is reduced, means from this to this, right? If you subtract, you'll get this strain, and that is your strain after time t. So you don't need to remember, because this is the instantaneous sigma naught by E, and you have to subtract this. This is nothing but this value is reduced by which factor? E to power minus t by tau. That's it. This is your equation. That's how I remembered it with my time. Now I, by seeing the notes, I am able to visualize. Okay, so this is a simple equation. You don't need to memorize, but it's okay. So this is, if this is the equation that you know, and I think that question is just a math. Come on, guys. You cannot think of it, but you need to know what is given. So viscoelastic behavior, Kelvin Voigt, blah blah blah. Then a spring ka, it's always better to write the diagram, guys, because that shows कि तुम कितना, this is nothing but how much is the eta is the parameter here, epsilon E is the parameter. So E is given as 10 MPa, and here eta is given as 3.6 into 10 power 11. Remember, it is in Pascal second. This is in megapascal. The moment you do not convert this into Pascal, you are making a blunder. Okay. So it's telling if fixed stress, so this sigma naught is a fixed stress, 40 MPa, you have to convert into Pascal because it's easy to convert it. 40 into 10 power 6 Pascal. Now it's telling suddenly removed, applied, thereafter the value of strain after 1 hour. So T is in, this is in second. So your T should be second. After this second, what is my strength? So we all know, guys, it will increase. The moment we remove it, it will decrease. So this is my strength. After time, let's say 3600. So this value we all know, it's coming from the spring, instantaneous deformation. What is the strain in spring? Sigma equals to E epsilon, right? So epsilon is sigma naught by E. So this is sigma naught by E. I just showed you. So this much, okay, sigma naught by E minus this value multiplied by this exponential decay, E to power minus T by tau. So sigma naught by E, E to the power minus T by tau. That is your epsilon at 3600. You have to put 3600 in here, and tau is your, what is tau? Eta by E, right? Eta is already given, E is already given. You can calculate your tau. Sigma naught is already given, E is already given, T is already given. Come on, guys, put in it, you get your answer. Okay, you don't need to worry about the, don't need to worry about the anything else. Is there anything that I should worry about? No, nothing at all. Okay, that's your answer. So at the last, I'm telling you, if you are watching still up to this time, okay, so we are going to start from March only, after GATE result declaration only, the the scholarship test. Please attempt that, and those who are watching this for GATE, please attempt that scholarship test, and you can get 50 to 100%, most probably 50. If you are in a below average or average students, if you are really achieving good marks in the test, you can get 7500 for sure. And join our regular batch to watch 200 plus 250 plus lectures. Daily one lecture will be given to you with the ultimate digging depth of whole concepts in whole polymer material. And then you can attempt the test series at the end of the October, November. You can join. Or else, if you're watching this to give the final GATE exam in GATE 2025, all the best to you. And just memorize formula, memorize fact, memorize graph. Don't ever worry about it, and practice the questions as many as possible. First, practice all the previous year question papers. That's all from my side. Thank you very much.